Okay, so good evening, everybody. Welcome back to the session. So we'll be starting in a couple of minutes. Please just hold till then. So we'll be starting in 2 minutes. Thank you. Okay, so great team. I think we can get started now. So it's already 5 minutes past. So let's get started, team. Just for a quick recap of what we have done yesterday. So yesterday we started discussing about something called as a configuration management tool such as Ansible. How does it help us implement a configuration changes across our infrastructure when you have a number of servers? How do I make my configuration changes across the infrastructure or across my various environments in the organization, right? That is what we discussed team yesterday. At the first part, basically, we try to understand about Ansible ad hoc commands, and we try to understand how to write Ansible YAML file called as playbook, and we try to run a couple of playbooks, and we'll see that how does Ansible controller machine was able to log into the target machine and able to implement the changes. So the whole thing team with that configuration management tool is that you will sit at one location and you will start configuring your entire infrastructure. Any change that is in your infrastructure, you can make it by sitting at one location or on one machine, which is called as your Ansible controller. Now that is what we understood yesterday, team. That's how we implemented the changes, right? Now that is for your infrastructure configurations, like whenever you want to set up anything, whenever you want to, upgrade a software, whenever you want to do something on your virtual machines, then, we can simply use a configuration management tool to perform all the tasks as per our automation is designed. That is the first part team that we understood, and the second part of the session we understood about what are containers, or the way we were hosting the application. Earlier days we were hosting directly on a virtual machine by installing Java, Tomcat and everything, for example, right? And we deployed our WAR file into a Tomcat server before the containerization. But after the containerization in the picture, we try to put all the dependencies into a single package, application plus all of its dependencies that are packaged together. Then we call that as a container. So instead of hosting your Tomcat Java separately or deployed separately across n number of servers, we packaged everything into a single bundle, and then we try to deliver our bundle, means our application plus all of its dependencies are deployed as a single unit, so that it will run, wherever you want it, regardless of any environment, it would run the same way, so that you could avoid a lot of issues that are environment specific issues that you are seeing in nowadays regularly, right? That is what the advantage that you get at the first point. And containers are also very dynamic, or very lightweight, we call it. It is easy to run your application whenever you have the image ready. That is what we discussed today. What is Docker image, what is a container, and we discussed all these definitions yesterday, team. And we also saw that when I have an image available, or from where do I get the images available, there is a public place called as Docker Hub, from which we can download all the Docker images which are publicly available. You can create your own private images also. That's what we're going to see today. But we try to understand yesterday again, whenever I have an image, how do I run a container from it, right? Now we used a command called as docker run -d, a detached mode container that we saw it yesterday. And we were able to spin up multiple containers from a single image. Like image is like a blueprint from which we can run multiple instances. And we also understood like how do I access my application which is running within the container, by publishing the port numbers on the Docker host. That's what we understood yesterday, team. And we also looked at the container lifecycle. When we talk about the container lifecycle, like container gets created, container can be stopped, started back, and restarted also if needed, or the container can be killed also because it's a simple process running on your system. Now, once you have these many tasking, I think at the end we can remove the container also, because whenever you prepare a new image, whenever you want to deploy a new version of your application, basically, we always deploy a latest version of the image, which means that we need to remove the older containers and start a fresh new containers accordingly. That's where we understood, team. I think you can see that on my screen also. That's where we downloaded a couple of images from the Docker Hub, which are already having some application in it. We saw that we were able to access application by running these images as containers, right? We saw that how we are able to run the containers and everything. We saw it yesterday. But today, team, we're going to understand about the target is that how do I prepare this image, right? A lot of people have a question on this one, like how do I prepare this image when I have a set of instruction with me, right? When I have a set of instruction with this, how do I configure or how do I prepare this image of my choice? And then once you have the image ready, then we can run the containers again wherever we want it. So we need to understand a few things, team, here. How do I create my image here? So that is why, team, we're going to talk about running a container again, because, team, whenever you want to install a software or install or deploy your application, team, the base thing is always operating system, right? Likewise, also, team, in every image that we had it yesterday, also we discussed that the base layer or the basic thing is called as your operating system library. Now, on top of it only, you normally install everything, right? That is how it, like you have a virtual machine with an operating system available already. Then on top of it, you install Java, then you install Tomcat, then you deploy Warfare. So that is what we understood also with the configuration management already. But within the containers, team, again, the container is like a logical unit, or it's just a unit or have it, within which also we have an operating system library that is nothing but an image, we call it again, from which we can start customizing our own stuff, right? Which means that, team, today, team, we are going to discuss about a process called as how do I create my images. That is what we're going to discuss about, how to create, right? So create a Docker image. This is the concept we're going to discuss about it. A Docker image. This is what we're going to learn, team, today. So whenever we're discussing about how do I create my Docker image, there are two ways, we call it. There are two ways, right? I'm going to walk you through quickly what are the two ways, right? So let's say that what are these ways and how do we do it? Let me reduce the font here. Here we go, right? So there are two ways we call it, team, always. One thing is called as your manual process, right? Manual process we call it. Then there is something called as an automated process. So we're going to look at quickly both of these processes team. I said it is essential that you need to understand both of these things. Now this is what we're going to discuss today quickly for first 1 hour, and then we'll try to go for the next topic accordingly, whatever is necessary, right? So this is the two processes team that you need to understand accordingly, correct? Now when I'm talking about the two ways team, try to understand that since we need to have a base image or base operating system, on top of it we can customize the things. Now there are many base images available team, like there are many operating system images available within the Docker Hub. Let's say that I want to customize my application. I want to run my application on an operating system called as Ubuntu Linux, or maybe CentOS Linux, or whatever it may be. There are different types of operating system that you have it within the systems always within the. So how do I choose this one according? Now let's say that team there are many operating system images available within the Docker Hub. Let's say that this is my Ubuntu operating system image itself. So I can take this image, right? I can take this image and I can start customizing my own application on top of this one. Now this is how team you need to understand about it. You have to take a base image always. Whenever your manager maybe asked you like, okay, I want to deploy my application on a basic operating system called as Ubuntu, a specific version of Ubuntu otherwise, and then you must customize, let's say that install Java 1.11 and install Tomcat 9, and then you have to run your application accordingly. Now that is what is called as customization team, and that is what how you need to run your application also based on the requirement that you need it always. We must do it. So that is how team, that is the reason a Docker provides always the base images, we call it. A base operating system images are provided by the Docker. They're all available within the Docker Hub again. Instead of downloading our application images yesterday, for example, we're going to download this base images. We're going to download these base images, and then we will start customizing this image, and we'll build up our own stack on top of it, and we prepare our own package accordingly. Now that is the process of creating a Docker image team, we call it. So let me get this image first of all, which is called as Ubuntu, right? So maybe team Ubuntu have a different versions, like that every software has a different versions of operating system. Likewise, we also had our image with version 7, version 8 yesterday. Similar to that one team, Ubuntu is also an operating system which has a various versions. Now within the Docker Hub, if you are talking about various versions of your images team, that is nothing but we call them as tag. A tag is nothing but refers to a version always. If you do not mention a version, it always downloads the latest version, that is the latest tag will be there. But if you want a specific version here, likewise we can see that there are many images available, right? A groovy something, there are minimized customized images which are provided by your Docker Hub. So you can say that 2010 is the latest version maybe, right? 2004 is there, or let's say that 1804 is there. So likewise team, there are many Docker image versions will be available within the Docker Hub. You could pull whatever you want to do it accordingly. Now let me take a specific image team here today, just for our example. I'm going to do it. I'll show you how do I prepare my Docker image customization as per my own choice. Let's try to understand, right? So I'll go to the my system team. This is my Docker machine that you had it yesterday. So within which we already have some images already, but these are the images which we already used it yesterday. Let's say that I'm going to pull an image called as Ubuntu right now. Docker pull Ubuntu, I'll say it. Let's say that 16, or let's say that 1804 is the version which I wanted. Now this is how team you can simply pull a Docker base operating system image first of all. Now once this image is available, right? Once the image is available team, I'm showing you the manual process team first of all. Let's discuss about how do I prepare my image in a this one. Let's say that. So here it is. We call it, let's say that the manual process team, which I'm calling it manual process. Now within the manual process team, always within the manual process, that is what it is, right? Within the manual process team, we take a base image always. Base image is what we take it. Now after you take the base image, basically run it as a container, right? Run it as a container. That is what I'll say it. Run it as a container, whatever it may be, right? So you just have to run it as a container. Now once you run it as a container team, we can get inside the container. This is just I'm writing team just to write to understand, get inside container, because within the container now, because we have to build a package that is always within the container only. Whatever you run it, whatever you want to install, that will be within the container itself. That is a manual process to do it. Now within the container team, make the changes, right? Make changes within the container, right? Within the container. This is what the steps team. Now once you within the container done it, you can come out of a container. come out of container again. Since the team, we understood that yesterday also, whatever the changes that are available within the container are temporary changes only, right? If I remove the container, the changes within the container will be lost. Now this is where team, in order to prepare an image, we say that commit container changes, right? Commit container changes. Now that becomes your new page, right? So that becomes your new image. That becomes your new image. That is what this is what is the process team with a simple process we call it. I know this is looks this one here, but let's look into this as step by step basically. Now you have taken a base image team already. Let's say that you pulled a Docker base image, which is Ubuntu 18.04 image. That is what we call it, right? So we had a base image here already. If you look at the Docker images output, that you will see that there is a base image that you have it available. Now, once you have this image availability, now we need to run it as a container, right? That is what we learned it. Now we know that how do I run it as a container team? Yesterday we already learned it. Now this is what it is. Yes, yesterday team we ran it as a container using a Docker run command. We used something called as -d parameter, detached mode, right? Now this is where team you can run a detached mode this container also, but let's say that I'm using the image name, which is going to be your since name. This is a plain operating system image, which there is no process, so I do not need to publish any port number. When you have application within the image, always you can publish a port number, otherwise you do not need to do that. Within this plain operating system team, we do not have any applications as of now, so I'm not going to publish any port number for this. Now along with that team, if you try to understand yesterday also, there is one thing which I've shown you, like whenever you run this image as a container, the Tomcat process was initialized within the container automatically using a command column, that the command was there. Now within this one team again, there is no such process that is available for us, so we must create a process always. If it is not available, it is not going to start any default process for us, so we can create our own process of our own choice. Since we want this container to be live team sometimes, so what I'll do is that I'm going to make sleep it. I'm running a command at the end, which means that this is going to run this particular command right now. This is going to run this particular command right now within the container. A sleep is a process team which is going to sleep for the number of seconds that you say it. Let's say that I'm saying 3600 seconds here, which means that it is going to sleep it for an hour from the time of a container creation. That is what all it is going to do it. Now this is how team I'm running my container in this detached mode with the Ubuntu, that is a plain operating system, nothing else available. And we are creating a process to ensure that my container lives in the background. That is what all I'm doing it. Now run this container team. Now this is going to run it. Now if I say this Docker PS, if I say Docker PS, now you can see that my container is up and running. Now there is a sleep command that is running. We know that the default operating system images does not have any default initial processes, default init processes basically. So we are created a process automatically. When we are running a container, we can create our own processes, which I want. Now in this case, I created a sleep process. This is 3600 seconds, which is going to sleep for 3600 seconds, which is almost an hour. It is going to sleep it. Now team, I have a container, right? Try to understand that I have a container running here. Now I want to get inside this container to do some changes within the container, right? That is what all we need to do it, because whatever we build in, we have to build within this container itself. Now, how do I get inside this container? Try to understand it. We are on the Docker host right now, where the Docker software is running and where the Docker container is running. Now, within the container team, the container is also having an operating system library there, right? Within the container also, I can perform some changes, whatever I wanted. Now, within the container, how do I get inside a running container team? That is what all you need to understand. So in order to do that one team, like whenever you log into your this particular system, we use a terminal basically. Now this terminal team, this is called as a shell terminal basically. For a general operating system, you always have a general shell terminal with which you always interact with it. Now, similar to that one team, since we have an operating system within the container also, that would also have a default terminals. We can interact with that terminal. Now, that is where team, we say that if I want to get inside a running container, let's say that Docker exec is a command, because Docker run is a command which creates a container, but what is Docker exec is a command which gets me the interactive terminal. I'm asking you to give me an interactive terminal so that I can interact with the container. Now within this one, which container I want to interact with, you can use the container ID as an interactive one, because I would like to interact with this container. And within the container team, there is a default terminals will be available like bash or something. So we must give the terminal process, whatever it is, the bash process, bash terminal, which I want to get it. And this is how I'm giving it. Now look at this one team. As soon as I execute this command, which will go inside the container, you can observe the difference in the screen right now, which is where it is. We were on the Docker host. This is my Docker host host name. Now, when I get inside this one, I call it root at the rate container ID. The container ID is nothing but the host name of your container. You can think about it. Right now, team, we are within the container. Within the container, we are now within the container team. You could do whatever you wanted. Now, this is just like your general operating system only team. You can run every command. This is also general things. You have every directory structure here also, but the only thing is that it will not be a full operating system. This is a minimal operating system library where all the functionalities of your general operating system will not be there accordingly, right? Now team, here within this one, I could do whatever I wanted. Let's say that I can create a file, because whatever you do within the container team, that is called as a change within the container. Let's say that let's say that naresh.txt I'll create, right? Naresh.txt I'll create. There's some file I'm creating within the container, means the general operating system did not have that, but after I creating a container, within the container, I'm making some changes of my own choice. Whatever the way I want to build my own image, I'm making some changes accordingly. Now let's say that I want to add or I want to modify this file using a VI editor. Is that VI Naresh.txt? Okay, so which means our team, the VI is not found here because this is the minimal operating system library again. The minimum operating system libraries will never have these kind of functionalities because these are all things which are not required by your application anyway. Now this is how team you can understand about it here. The VI command is not found. So let's say that I want to install a VI editor, that is also considered as my change again. Now let's say that apt get update I'll do it just like you do it on a general system team. This is since Ubuntu, the package manager remains same thing for me. I can run a command called as apt get update, which runs some updates within the container. It will add something within the container again. Now once after this one, I can install whatever I want it also. Apt get install vim, right? This is what all I'm doing it, right? So here it is. This is how you can simply install it. This is a command to install something which is within the container again. We are installing within the container. On our Docker hosting, we already have the VI editor, right? But within the container, the VI editor was not found. So I just installed it whatever I want. Now, once I installed the VI editor team, you saw that it is installed successfully right now. Now, once it is installed, I can use a VI editor to modify some file. Let's say that this one. Now I'm able to open it, which means that VI editor is installed successfully. Now let's say that hi there, right? Hi there, right? Let's say that this is my first Docker image. Right. This is what I'm just putting it. Just some random text within the file. That's all I'm putting it. Now let's say that this is what all I prepared. Now within the container team, try to understand that we have taken a base image of Ubuntu operating system. We ran it as a container. Then we got inside the container using a Docker exec command. Now once you are inside the container, you went inside the container, you did multiple changes like created a file, you did some update, and then you did install your VI editor, and then you also did something called as modification of file, and you put some of your own text accordingly. Now these are all the changes thing that we have done within this container. Now I can come out of this container, but I mean still inside the container team. I mean still inside the container. Now we need to come out of the container first of all. Let's say that I can come out of the container using exit command. So just type exit. Now you see that team, we are exit, which means that from the container, from within the container, again, we are back to the Docker host. That's what you see it. Now here team, if I say a Docker PS, now your container is still running up and running here, which means that team within this container now, whatever the changes that we did so far, like I created a file, I did up some update, and then I did install VI editor, and I did modification to my file. These are all a couple of changes which I made it within the container. Now, as long as this container is running team, whatever the changes that I've performed within the container will be there. But if somebody removes this container, my changes will be lost, right? My changes will be lost basically. Now, how do I make my changes permanent? That's what I told you yesterday, team, that Docker images are immutable actually, that cannot be overwritten. Whenever you want to perform some change, whenever you want to modify something, you create them as a container. Within the container, you make whatever the changes you wanted. You come out of the container and you commit the changes. Means whatever the changes that you did it now, if you want them to be a permanent thing, you must convert the container into an image. That images are permanent, the containers are temporary, always within the Docker host, right? Now this is where team we use a command called as Docker commit command, right? I can use a -m image, and let's say that my Ubuntu, you can message anything team. -m stands for message here, which is saying that, okay, what exactly you did changes here. Let's say that I'll put it something called as install via editor. That's all I did it. Now here team, which container we are committing to become a new image, right? Let's say that this is a container which we are committing it simply. And then you can see that here, what is a new image name that you want to give it. Let's say that this is my Ubuntu, I'll call it, because the default Ubuntu does not have a VI editor. My Ubuntu image, my own customized Ubuntu image will have my own VI editor accordingly. Let's say that I want to version this one also, my Ubuntu version 1. This is what all I'm calling it. Now this is how team you could create a Docker image simply. When you run this command, basically it is going to create an image which is just generating your image ID accordingly. Now let's say that if I say a Docker images output right now on my system, you would see that my Ubuntu will be there. This is the version 1. Try to see that team. We had a base image called as Ubuntu 18.04. That is the base image that we took it. On top of it, we created as a container. Within the container, we made changes. Now the container changes are committed as a new image so that you have an older image as it is. Since older images cannot be overwritten, the Docker does not allow you to overwrite any image here. That is not a process. That is why we say that the Docker images are immutable, right? They cannot be modified once they create it. You can do the changes by creating a container, and you commit the container changes as a new image so that you have an older version as it is safe for you. And then you also have a new version of the image. And then you can deploy your new image as containers again if you want to do it. Now, this is how team we say that this is the process of creating an image basically. I hope you all understand that one, right? This is the first way of creating a Docker image team from the container changes, we call it. Creating a Docker image from the container changes is called as using a Docker commit command. That is the first way of creating your Docker images accordingly, right? Now, this is what it is called team. This is how you prepare your image. Now, you see that my Ubuntu image is successfully prepared here. I have my own image available for me. Now this is what it seems. Since we did not really put any application in it still, so it is cannot run any application still, of course. But let's look into a realistic approach, team. A realistic approach. Instead of doing a manual process, here team we did only a couple of changes. But let's say that in real time, I want to really perform up multiple steps which comprises my realistic image where application will be running everything, where you might have a number of instructions for it. How do I write or how do I build the same thing with an automated process? We'll try to understand the same image thing. The way you did it right now, you take the base image, you convert it as a container, and then within the container you went in, you ran some changes and you came out of the container, you committed it. But instead of writing this one or instead of doing this process, basically Docker provides an automated process also. Now, what exactly this automated process or how do you do perform this automated process? Now this is called as your manual process team. That's what you see it. Now when come to the automated process here, let's say that automated process. Now this is the way team we say that our Docker says that you must write a Docker file for it. I hope you might have heard about something. I'm not sure if you heard of it. There is something called as a Docker file. A Docker file is a script team. A Docker file is a plain text file, we call it, which is having a set of instructions, right? Which is having a set of instructions. How do I build my Docker image? That is what is called as Docker file team. This is how you can simply, build a Docker image also. Let's consider the same steps in because I want to replicate same whatever the manual process I want to convert into a automated process, right? That is what we do it. Of course, right, in real time also, whenever you see the manual process, we try to automate that process to make our life easier. Let's say that here team, we are also doing the same thing. First of all, we need to get the base image. The base image is nothing but your Ubuntu. That is the same thing. I'm taking it again, Ubuntu 18.04. This is what we took it. Now we need to run it as a container. Of course, we need to tell Docker how do I run it as a container. Of course, our team understand that once you run it as a container, within the container, we ran a couple of commands, right? Let's say that this is what I do it. Let's say that touch narration.txt. The first command which I ran it within the container was this command. Now after that, I ran a command called as apt get update. I'm just listing out the instruction team. We can give this one to the Docker. So Docker runs these commands on behalf of you. Now after that, I also install something called as apt-get-y install-y vim. This is the command we ran it again. Now finally team, we also put some text message. Since we cannot vi that can be done interactive mode here again, we can use a simple command called as echo like that. Hi there, just to update the file called as narration.txt, right? So this is what I'm just doing it. I'm just appending some text to the narration.txt file. That's all. So likewise, this team, this is the instruction that we run it within the container, the manual process so far. But instead of you run these commands now, team, instead of you run this one by one at a time, we need to ask Docker to run this one. Means that Docker is going to read the file called as Docker file or any file basically that you write it. Now, which will have to understand these instructions. Now that is where team, that is where Docker provides something called as Docker file directives. Means Docker understands a predefined syntaxes or syntax words we call it, that way you need to use it accordingly. Now let me introduce you that one team. Let's say that there is a keyword called as from. Now let's say that there is another keyword called as run. What are these instruction team? We'll try to understand it. We'll try to have these Docker file instruction team. There are only few things, around 10 to 12 commands. You don't need to by heart it also sometimes. So they are very easy to remember. Simple things to do, right? Now try to understand team. This is a proper Docker file right now for me. Means I can give this Docker file to my Docker right now. I can use a command to build a Docker image using this Docker file, right? Now what exactly we are doing it here, if you understand team, a from is a keyword basically which always chooses a base image, chooses a base image from which you want to start your changes always, right? Let's say that here, likewise to get Ubuntu is a base image we want to get, and on top of it we want to make the changes according. We want to prepare or we want to customize our own changes on top of this base image according. Now whenever I say from team, a from is a keyword which is given by the Docker. It is a predefined one that must be in capital letters as you see it. Once you have this image or this keyword, Docker understands, okay, you want to take this as a base image. Now it also runs it as a container automatically, because once you have a base image, you must run it as a container. Within the container, you need to perform some changes, right? Now this with from statement team, Docker is going to understand that, okay, you want to take this as a base image and you want to run it as a container also, so that you could start making the changes within that container. And that is what happens basically within one syntax here. Docker takes the image and runs it as a container, keeps it open for running the set of instructions again. Now, whenever you want to run an instruction within the container, right, within the container, right, we want to run the command called as this one. This is a general Linux command itself, the way you run it. Now, this is where we are asking Docker to run this one. That is where Docker uses another directive called as run. Whenever I say run, okay, Docker understands this is the command you want to run within the container. Okay, the first command and the second command and the third command and finally the fourth command. Whatever the instruction that you want to run within the container, you can use a keyword called as run within the in front of the same command that you used manually. The same command can be given here. Now this is how team I can write a simple Docker file, a very simple Docker file for you. Now this is how you can write it. Once the Docker file is addition, you can say that vi Docker file. I'm just creating a file called as a Docker file. The file name can be anything, team. It doesn't matter what is the file name. I can even say that, let's say that narration file also I can say it. That's fine. The file name can be anything, that doesn't matter. The only thing matters is that what are the instructions, whether you write a correct instructions within the file or not. That is what. But generally we call this as a Docker file for just understanding the file. Let me create that itself. Let's say that a Docker file we call it. Right. Within this one, I'll just copy paste this instruction. Only the 4 instruction here, which I'm just doing it. Now save this file, save this file. Once you save this file team, now how would I give this instruction to the Docker, or how would I give this Docker file to the Docker so that Docker would read this Docker file line by line? It will start executing the things on behalf of you accordingly, right? Now this is where team we say that we must use a command called as Docker build. Instead of Docker commit team, whenever you want to create an image from the container change on your own, that is called as Docker commit. Whenever you want to build an image from a Docker file with a set of instructions in it, we must use a command called as Docker build. With the Docker build command team, you can provide the file name, whatever the file that you have it. Let's say that -f is a parameter, we use it. Now with this one, you can provide the absolute path where the Docker file is exist. Let's say that -root I think the file name is Docker file. You need to provide the full path theme here where the Docker file exists on your file system. This is how I do it. This is where my Docker file is exist. Once you have given a Docker file name, you must create a new image, right? What is the new image name? Now that is where we must use a syntax called as -t here. Tagging we call it. Now let's say that this is my Ubuntu itself, I'll call it. Still we are doing the same thing, but this is my version 2. Version 2 is a little bit different, think about it, but we are doing with the automation process. So my Ubuntu version 1, I created a manual process, and a version 2, I'm creating as a different automated process. That's all we are trying to do. Now at the end team, there is something called as a context that we need to give it. What is this context? We will understand it. Right now, think that you can give the current directory reference from your Docker system, because the image must be created on the Docker host itself team. So it needs some file system reference where it can refer all the documentation and everything. That is where we are using the current directory as the current file system. You can use the current file system architecture to build this Docker image accordingly. So we'll try to understand this context more, but there is a dot at the end is mandatory. There's a dot at the end is mandatory for this syntax. You must use it accordingly always. Now execute this one team, just enter this one. We'll see how it's going to do it. Look at this, it is trying to do something. It is getting something here, and whatever it is trying to run on its own. I'm not doing anything. So it is going to run everything automatically. It is going to run everything automatically for you. And finally, it is going to say that the image is built successfully, right? That is what the outcome you get it. So here it is. Now you have this image ready team. See this. You have the image created. It says that successfully tagged or successfully built some image, successful tagged, which is called as this one. Now this one thing you can say that when I say Docker images right now, you should see a new image, which is my Ubuntu version 2 is which I built it. Now this is just built as 14 seconds ago, right? Now this is how team we could build our own Docker images with a manual process and with an automated process also. But here team, I just went through a very basic example of how do I convert, how do I build my images. But let's look into a realistic image team. Like we generated our WAR file. Now I want to put that into an image and I want to build an image for that one. So how do I write my instructions for that? Right? That is all what we need to understand team. Let's say that the instructions and Docker files are the few examples I have given team within your Docker repository here, which is a GitHub repository which we shared with you guys. If you go to the Docker folder here, within which you will see a images folder, right? Within which team I explained everything in a documentation format also. You can go through this document later. I'll just say this one, right? Now there are multiple examples. I have it here. You can go through this Docker file sample app example. Now within which team you see that there is some example I'm taking it for deploying your images, right? Let's say that here I can use something like this. This is an example one which I'm doing it. Likewise, with that, this is Ubuntu, and here team I'm doing an update accordingly, and I'm also installing a web server called as Nginx, and I'm trying to create some more directory structures here, right? So let's look into this one team, or let's look into a realistic image here, which is going to be your sample app. That is what it do it, right? So first of all, team, I think within the Docker, let's see that okay, there is a code available. I need the WAR file team. The WAR file is also I copied here. If you want to look at it, there are some WAR files. For example, we want to take it. So I have given a WAR file here. So what I'll do is one team. What I'll do is that let me get this repository to my local first of all, so that I'll get all the files onto my local. What I'll do is that I'll simply clone this repository onto my system. I'll clone this repository onto my system so that I'll get all the stuff. I said that git clone, I'll do it. I'll get this repository onto my local. Now, once you have this repository on the local team, let's get into that one. Let's say that this is DevOpsUniversity, right? What is the folder name we got created here? Okay, it is certified DevOps, right? So this is a folder that we have created. Now, within this one team, you will see whatever was there in that one. Now, if you go to the Docker folder team, which is going to this folder, now here you will see something called as the images folder. Now within the images folder team, you can look at it. Now, there are multiple Docker files. I have it right here. It is. If I go to the Docker file called as this one, now this one team try to understand a simple thing. I'm doing it basically. What I'm trying to do is that instead of building from the scratch, means you can take a base image as your directly a Tomcat image team. We saw that there is a Tomcat image already available within the Docker Hub. So we are taking within that image, you already have an operating system. You already have a Java, you already have a Tomcat within it. Now I just want to deploy my application. Now this is also, you can choose a base image team. It is not that you can always start from the scratch like operating system, but it is that you can always use a existing image to deploy your applications directly also. Now in this case, I'm taking an example called as, I'm getting an image from the Docker Hub, which is called as Tomcat, which is already available Tomcat image. Within that image, you already have a OS library and you have a Java installed, you have a Tomcat already installed. So with that team, what I'm trying to do is that I'm just simply copying my WAR file, right? Now this is the default location team that comes up with that image always. You can simply, do this one, copy to the web apps folder so that your application deployment will be complete. Now, once you have that one team, once you have that one, the copy is a new instruction that you're seeing it here. Copy is a new instruction here. The copy is something from your Docker host into the image while you're preparing it. That is a copy statement that we can use it. Now there is something called as export statement, means what Tomcat port number is going to run it within the Docker container. That is what the number we are giving it here, so that external people will come to know that, okay, whenever whoever uses this particular image, okay, they will understand that within the container, the process will be running, or Tomcat process will be running on a port number called as 8080, right? That is what they're going to understand it. Now there is also command field team, like you understood that in order to start a process within the container, we must provide a default command for it. Like as part of your image build process, we would provide a default command that will be triggered whenever somebody uses this image, or whenever somebody runs this image as a container. This is the default command that will be executed within the container. So this is responsible for starting my Tomcat process within the container, because the whole purpose that we are building this image is that our Tomcat should be started automatically, right? Now that is where I'm setting up a default command. Like whenever you set it in, I think whenever you know that the Windows services, or whenever the operating system comes up, your general virtual machine operating system comes up, there are many services comes up, right? Similar to that one, here we are also, whenever this image starts up, the default command that will be running it, that will be starting your default process within the container accordingly. That is what all we're trying to do it. Now this is the simplest image team, we can create it accordingly, but the question is that where is the sample of path file, right? How do I, because I did not provide any path team here, the path must be provided on the command line while you're building this image. That is what we call it as a context, right? Now again, I'm coming back here. So where is this file exist? That path need to be provided on the command line. That we call it as a context. Always, whenever you want to copy something from a Docker host into the Docker image while you're preparing it, you must provide the path that is called as your context. Now let me show you this. First of all, where the sample of var file will be present on my system. If I go to this particular folder team, I think within the Docker folder, there is a code folder available for me. This code folder is where I have the var file available, the sample app var file, which is available here. Now this is the path team, try to understand. This is the path, is my context becomes right now when I want to build that image. So let me get back to the image folder, right? Here team, I have the Docker file. Let's say that Docker build is a command. I'm using it again. -f, whatever the file name you have it, you can simply use this one, or you could provide the absolute path also completely, because we are already within the images folder. We can simply provide the file name itself. Now, once you have this one, what is the new image name? Is that this is sample app is what I call it, because we are deploying a sample app application here. Sample app is what I'm calling it. Let's say that this is my V1, right? This is what all I'm building the image accordingly. Now this is how team you can simply build it, and then as I told, like the sample of var file exists in this path. This becomes the context for me, because we did not provide the path where my var file exists on my Docker host within the Docker file, and that must be provided at the end, and that becomes earlier image team we provided a dot. We still don't copy it, but we still provided a path there. But this time I'm providing this path so that it is going to take the var file from my Docker host and going to deploy it into the image accordingly. Let's say that we'll see this one. Now you see that team, this is very quick. It's already done. There are only few steps here from Tomcat. It got the default Tomcat image. It copied my var file immediately. It was quick, and it exposed the port number. It also gave a default command. Now finally it says that it built the Docker image successfully for you, right? Now once you have this one team, let's get back here. Let's say that Docker images. See that team, I have provided something called as here sample app and then the V1. This is what are we doing it. Now, if I want to run this image as a container team, you know that what is the drill again? Let's say that docker run a -d, because this is going to run my application also. Now I need to publish my port number, so I'll use a -P option, right? Once you have this P option, you can simply provide your image name, right? V1. Now I'm not providing any command at the time at the end team like we provide for the default Ubuntu, right? Since this is already having a default command set, the default command would execute it automatically, which would start my Tomcat process accordingly. Let's say that here I ran it. Now you can see that the docker ps command. See that team, our application is running successfully here, and you see that the command that we have given is executed here, which have started my container successfully, a Tomcat process within the container accordingly, right? Now, once you have this application available team, you know how to access this. You can simply use the port number of this particular machine and the host IP address of this machine. Let me get back here. So this is IP address. This is my system team, one system here. This is good. Go to the browser. Sorry, here we are. Use the port number team, which is 3276, I believe. Now this is where team, you can see that Tomcat is responding, or within which we actually deployed our sample app. That's that sample app is what I'm using it. Now you see that your application is launched, right? Now this is how team you would build your own Docker images by writing a Docker file, and within the Docker file we would write our necessary instruction to build our own Docker file, our own images accordingly, the way you want to do it, and you can copy your images or WAR files within the container, within the image, and you build your own stack according to your requirement always. Now this is how team we could build our images, whatever the way you do it, whether you go for the manual process or you go for automated process, it's up to you. It is up to you, but this is how we normally build our Docker images in a real-time environment also. Most of the time we use a Docker file, 99.99% we always use a Docker file to build your Docker images in real time, so that we could track the versions of your Docker file also. The commit or the manual process was to just to make you understand thing, just to make you understand how the containers, the images can be prepared a layer by layer or a step-by-step process. That's what I was showing you. The second thing is a realistic one. Once you understand the manual process, you could start writing a Docker file for appropriate instructions like we did it. So you could build an entire image of your own choice by writing set of instructions within the Docker file and execute the Docker file, which will become, which will become your the Docker image accordingly. Then once the Docker image is available, once the Docker image is available, team, consider that my Docker image is available right now, right? Consider that my Docker image is available. Now I can publish this image team into a centralized repository such as Docker Hub. Once the image is published onto a Docker Hub, once the image is published onto a Docker Hub, then we can start taking out wherever you want it, like any environment that you want to take it. Like in your organization also, you would have multiple environments where you want to deploy this image as a container. So we will simply pull that from the centralized server again, just like a Docker Hub, and start running them as containers or various containers within your organization. Now, this is the process of Docker image creation team. I hope you all got some idea now. How do I prepare my Docker images? Of course, you need to learn a lot of things here, but this is the very, very basic understanding of how do I prepare my images, both the manual way as well as the automated process. This is what all you need to understand, team. Now we will try to publish this image, team. We will try to publish this image into a Docker Hub first of all, right? And we'll see that once it is available there, everybody can utilize this image according to your requirement. You can even download it. I built the image. You can use the image if you want to do it, download it and start running as a container and start using things according to your requirement. Now, in order to publish this image into a Docker Hub team, in order to publish this image into a Docker Hub, you must have a Docker Hub account. Assume that you can create it. Please do create your Docker Hub accounts. Let's say that this is the default page that you see it, but you could log into your Docker Hub, or let me log in front of you. Maybe let's see. Here, team, this is the default page that you see it. You can sign up if you did not do it, or you can sign in if you already have an account here. Let's say that I click on the sign in option. It will ask me the login credentials. This is that Learn DevOps is my login. I simply log in here. Once you log into your account, team, it will ask you to many options. There's like a repositories option here. Within the repositories option team, you will see that there are many repositories which I created available for me, like sample app or whatever it may be. You could also create your own repository if you would like it. Let's say that create repository, and you must mention your repository name team. We can do it accordingly. Let's say that sample, right, app, right, D. I'll call this is the repository team. I'm calling it in sample app du. That's all I'm calling it. Now within this one team, within this one, make it as a public, but if you make it as a private, it is going to charge you. So ensure that you make it as a public. And finally, you create your repository, right? Once you create your repository here team, we must upload or we must push the image to the Docker Hub. That is what all we need to do. Now, how do I push my image into this particular repository, which is this is the repository name team, and within this one, this is called as my Learn DevOps is a Docker Hub account. So how do I push it, right? Now that is waiting. You have to come to the command line first of all. You have to come to the command line first of all. Let's say that the first of all you need to log into your Docker Hub account using the Docker login command. Docker login command. It will ask you the Docker Hub credentials for you. Let's start learn DevOps, whatever I provide on my website, right? So we can log in team. Here it says that login succeeded, which means that it is directly connecting to this one right now. So docker.io, that is where it is connecting it. Now, once this is successfully logged in team, you may think that we can directly push our images right now. Let's say the Docker images. Now, this is the image team that we prepared it. We want to upload it into our Docker Hub account, right? Now, how do I do that simply? Let's that Docker push is a command to user team. Try to understand this is the image I want to upload it. We will try to understand a few things here. Now, this is the image name team. This we're trying to upload it. Let's see that if it is going to do it or not. Okay, this one team, of course, it is going to throw an error for sure. Why it is? Because it says that requested access to the resource is denied. Why it is denied? Basically, if you try to understand team, the push refers to the repository which is called as docker.io, which means that the Docker Hub, but it is going to an account called as library. Library account is not our account, right? Our account name is Learn DevOps, right? Our account name is called as Learn DevOps basically. Now, how do I push into my account? Because there are many such accounts available, team. When you push a default image name like this, Docker does not understand within the Docker Hub which account you are pushing it to. Now, that is where Docker says that you must name the image properly. Name the image properly with your Docker Hub account name slash what is the repository name within the Docker Hub account name. That is what you need. So we must rename this one team, or let's say that we must create an alias or separate name for this one like this. You can say that you can create alias name for team. We are not going to replace the name or we're going to rename it. Rename option is not available, but we can create an alias name or we could create multiple names for the same image here by the different things, right? Let's say that Docker tag is a command basically. We can use it, right? You can tag in this image, which is this is the image we want to tag it as this is the image we want to tag it as my Docker Hub account name, which is learn DevOps slash within the Docker Hub account, what is the repository name that you created, which is sample app du, right? This is the repository name I create. Sample app du, this is the repository which I created. Right now we have nothing images, no images available within this repository. So here it is. I'll go here within this one. I want to store that as a version 1 image for me. Now this is how I tag it. Let's tag this one. Now once you this one team, if you see that Docker images output, now you will see that team there is an image available like this, which is learn DevOps sample app du, which is v1 sample app v1. Both are same images team. Like that, this is the same image ID you see it, which is the same image ID, which means that only one image exists on your system, but it has multiple names to it. Now that is how you can identify this team. Both have a same image ID, which means that it is a single image only, but it has multiple names to it according, right? Now you can push your account name team here, Docker push. You can refer to this one right now. Now this time it will understand, okay, I need to go to the Docker Hub. Within the Docker Hub, I need to go to account called as Learn DevOps. And within that one, this is where I want to push it. If you do this one right now, you will see that team, it is going to a docker.io. Within that one, it is going to a Learn DevOps account. And then within which it is going to a looking at repository called as a sample app du repository. That is what all it's going to do. Now this is how team you can simply upload our images into the Docker Hub once the images are created. You could create as many images as you wanted. You can create as many repositories as you want. You can upload them according to your requirement team on the Docker Hub, but that will be a public one. That will be public one. If somebody likes your code, they can take it and they can do whatever they wanted, because it's like, some proprietary codes are cannot be publicly quoted. So in that case, team, we will use a private repositories within your automation or behind your firewalls. That is where we have to vote upon. But this is a public one. Means right now, team, once this image is uploaded, you can also download this image onto your machines and you can start using the image according to your requirement. You can run it as a container. You can run it as many containers as you wanted. Likewise, team, again, Docker, I built it on my machine. You could ship that into your own machine and run it as you wish it. It will run successfully without any issues for you. Without any issues for you. That is what it is going to do it. Now, this is the same thing, team. This is the advantage of a Docker basically. You could build anywhere a Docker image, you could ship it anywhere, and you could run it anywhere as you wish it. So this is what it is, team. So let's say that it is almost uploading, pushing it. Not sure what is in here. Let's say that refresh. I'm just refreshing this repository. Maybe it is uploaded here. You can see that a V1 is uploaded here a few seconds ago. You can see that a V1 is successfully uploaded here, which is a few seconds ago, right? Now that is how, team, you can understand it. Here also it is done. See that it is done successfully. Now this is how, team, you could upload your Docker images onto your Docker Hub as you wish it. Prepare images, right? We understood how do I run the containers from an image which is available yesterday completely. Container lifecycle. There are various Docker commands we understood about it. How do I get inside a running container? Also we understood it. Now, once you understand all these things, we prepared our own Docker images, couple of multiple Docker images. We did it with a manual process as well as the automated process. We tried to build a realistic image with all the application deployed in it. And we also learned how do I push it into the Docker Hub accordingly. Now, this is all about the Docker team. This is about, there are many concepts in the Docker. I'm not touching all of them. This is all about the Docker that we wanted to cover here, but I hope that you must have now a minimum knowledge on Docker. What exactly is a Docker? How do I run my Docker containers from an image which is available? We can get the Docker images from the Docker Hub always, run them as containers, whatever the way you want it. Once they are running, you can publish a port number to access an application within the container. You could build your own Docker images as per your wish using a manual process or the automated process. And once the images are available, we could upload them into the Docker Hub to make it available for all the people who are on the internet. Now, this is just a process, team, I'm talking. This is just a process, right? This is the basic thing that you need to have it. Now, considering this situation, team, the next topic is going to be very, very much important. Now, this is most realistic scenario. Again, we use it. We're still going to talk about the containers only, but that is going to be in a different direction, right? We need to understand it accordingly, right? Now we are working team here. We are working here so far on a single system itself, right? We created a containers on my single host itself, right? We created a containers on my single host itself, team. Means I had a single machine here. Now I downloaded the image, I ran the image. Also, we ran multiple containers from a single image, which is equals to a multiple instances of application, right? So in a production scenario, team, how do I run my containers? Or what are all the challenges that I would face it if I try to run my containers in the production? Or in other words, how do I manage my containers across a different environments, right? In a production environment especially, how do I deploy my n number of containers, right? And how do I manage the containers in a production like environment, which is going to be a realistic scenario for you according, correct? Now we'll try to understand that one thing right now. We're going to understand a thing called as how do I use or how do I deploy the containers within a production environment. Now why I'm stressing on the production environment, team, a production environment should be always highly available. When we say highly available, team, means that we need to create multiple instances of our application, right? When I say multiple instances of application, it is nothing but multiple containers from the same image that you created, right? Now yesterday, team, we understood that how do I create a container on a single system, and how do I create multiple containers from the same image on the same system. Of course, you got multiple instances. You might say that we got the high availability for my application, but did we get the really high availability here, team? What happens if my machine goes down? Let's say that this machine is down itself. where all my multiple instances of containers are running. What happens to that one again, right? Now that is way team, this is not a good thing to run, or within your production environment, you always have a number of servers, we call it, maybe a hundreds of servers sometimes based on the application traffic that you get it, the number of users who are going to use your application. Like example, facebook.com is being accessed by millions of users over the world, across the world, we call it. Now, how many servers would my Facebook organization maintaining to ensure that Facebook application is always available, right? Now that is way team, in order to maintain the high availability of my application, we must deploy our application instances into n number of servers. When I say n number of servers, n may be 100 or n may be 1,000 also, I don't care about it. But how do I deploy these containers now across n number of systems? When I deploy them, should I have to, or do I have to log into each and every system and then deploy them, or can I sit at one location and deploy into all the systems again? This is called as deployment, right? Deployment. Of course, you may see that now, like I can use my Ansible, to run these commands across 100 servers. They will create containers across my 100 servers, because we understood already about the Ansible team. Ansible will help me to log into all 100 servers parallelly and run my containers across all servers parallelly, right? I could write some Ansible playbook, which will go there and pull the Docker image on 100 systems, run it as a container on the 100 systems. Absolutely possible. Yes, using Ansible, you could do that one. But is it deploying only your choice, or is there something else on the window? Means containers team are dynamic, we call it. Containers are dynamic. We need a sophisticated mechanism to manage these containers. Let's say that my containers want to communicate across multiple systems. How does my containers communicate across multiple systems? That is one of the challenges that you need to look into it, right? Now that is waiting, that is where we talk about it. We need a tool. We need a tool again. It's like Docker is a containerization tool, we call it. But in order for the container management across n number of servers, we need a container management tool, right? A container management tool such as a Docker Swarm or a Kubernetes team. Now we are introducing you to the Kubernetes basically. There are many container management tools we have it in the market. Container management tools are also known as your container orchestration tools. Container management tools are also known as container orchestration tools team, which will help us manage the containers across a number of servers. They will also provide a set of features like how does containers can communicate with each other. They provide a scaling feature. You can easily scale up your infrastructure containers, right? You could also scale down. You can do an auto scaling also. You also get an auto healing feature, and you also get an way that how do I access my application running within the containers, running we can across multiple containers also, we get these things. Now there are a number of features team, that is where I'm introducing you to the container orchestration team. The simple thing that you need to understand about a container orchestration is that this one, right? So the only thing that you need to understand is keep your questions in the mind right now. How to run or deploy multiple containers from a single image? That is what is the question, right? How do I run it? Should I have to run the Docker run command 100 times, like using a configuration management tool, or is it a better way to run it? Let's say that I want 100 containers from so and so image. I use a single command. It is going to create 100 containers for me. That is what. So the how to run or deploy multiple containers from a single image. Second thing is that how to run multiple containers from multiple images. Maybe a choice like we have different microservices or different applications. I want to deploy them all together. For every application, I prepared a separate image. I want to deploy these multiple applications in a single go. How do I do that? Again, how do I run or how to run multiple containers from a single or multiple images into multiple servers to achieve the high availability? Again, right? We saw that already we could create multiple containers from a single image in a single node already, a single server, but that is not a realistic production scenario. In a production scenario, we must create n number of containers across n number of servers, right? Means a parallelly co-located server like virtual machine 1, virtual machine 2, virtual machine 3. Like you may have different laptops, laptop 1, laptop 2, laptop 3, like that. You have different servers and run your application across multiple servers or multiple systems, so that will provide me the horizontal scaling, or which is called as high availability, we call it. Means that if one of my machine goes down, my application still will be available on my other system so that we could access our application without any interruption for the end user account. That is what is the waiting we need to deploy our containers on. That is where we are introducing you to the container orchestration team, or it is also known as a container management tool, such as Kubernetes is one of the container management tool in the market. Likewise, there are many container management tools such as Docker Swarm, or we can also say that a Mesos is a container orchestration tool. Like we have something called as OpenShift as a container management tool. Behind the Kubernetes is going to run it, but that is what it is. There are many things in the market. Likewise, team, this is what it is. So why container orchestration tool if you still have a picture, if you still have that confusion here? So help you to create a cluster, first of all, which is nothing but it is going to create a logical group of multiple servers, co-located servers. They will all going to communicate with each other as a single virtual system. That is the first option we need to create it. So all the systems within a cluster will be acting as a single system basically, or which will help us communicate with each other accordingly. Second thing is that automate the container deployment. Now we're using a container orchestration tool, we can automate the container deployment. That is what we can do it. And manage the containers across multiple servers. The container management tool going to manage the containers across multiple servers automatically. You need not to worry about anything on it. And provides additional features such as scaling, means you could scale your application instances as many as you wanted with a single command. Auto healing means whenever something goes wrong with your container, let's say now there are 10 containers running for me, out of which a container got hung sometime, it has to be restarted. In a general scenario now, team, you must go and restart it yourself. Until unless you restart it, it's not going to do it. But container management tools have an automatic feature like whenever it sees that there is a container is hung state, the process is not responding, the manager itself can take care of restarting it automatically. That is what you're going to do it. Enables communication across multiple containers running across multiple servers. Container orchestration tools responsibility to ensure that containers are communicating, because if I say that I have an application and I have a database container, there's application container, there is a database container available for me. My application container need to communicate with the database container. So how do they communicate with each other? This is a default networking that need to be built it. Again, this is by default provided by the container orchestration accordingly, right? Desired state values, maintain the number of containers requested always. Means when I requested or when I want to create 10 containers, now the cluster will maintain the 10 containers at all the time. In case if something happens to it, one of the container got deleted, one of the container got something happened to it. Now this is going to recreate that container automatically to achieve the desired state always. We will see all these things practically also, team, but let's say that theory part is this. Now, team, one last thing that a great feature is that a load balancing and the request between multiple containers or pods, we can call it. We'll discuss about what is pod, but this is how it is. Now, it is also help you to provide auto scaling, team. If necessary, it can do auto scaling also, which means that let's say that there is incoming traffic being watched. I have 100 requests. I have 10 containers running it. Now, all of a sudden, 200 requests came. Now, the cluster can automatically scale to 20 containers so that your 200 requests can be processed easily, right? This is called as auto scaling. Means I don't do it. I don't need to sit at my cluster. I don't sit at my systems accordingly to auto scale the things to create more number of containers. That is not required. The system itself can watch the incoming request like 100 or 200, whatever. You can define the thresholds. Like whenever I get 200 requests, create these many containers. That is one of the parameters that you can consider it for the auto scaling. Or you could also say that whenever I see the CPU of 80%, increase the number of containers to another 10. Or let's say that whenever I see the 80% of the memory utilized on my host, increase the number of containers to another 10, right? That is what you need. This is how, team, the container orchestration tools, container orchestration tools comes with the inbuilt features already, so that you would not need to worry much about how do I manage or how do I build my container ecosystem very, sophisticated and easy to use it within the production environment. Container orchestration tools already have these many features. Start utilizing them, right? Start utilizing them and we will understand them accordingly. Now this is where, team, I'm telling again, Kubernetes is a container orchestration tool. We must install this tool on our servers right now. As I tell, like A container orchestration tool is always a combination of multiple servers. It is not a single server anymore. We must take at least 3 servers to create a cluster. Then let's look at the cluster architecture here, team. Now, how do I create this cluster? Kubernetes as a container orchestration solution team. Let's say that for which I'm taking 3 different EC2 instances, just like we had for our Ansible. One is Ansible Controller and the target nodes. Here also we will take 3 different EC2 instances first of all. Now once you have these 3 EC2 instances, out of which like you elected your Ansible controller from which you want to maintain or do some configuration changes, everything on the target system. Here also team, we're going to elect a node as a master node, we call it. A master node is something to which we can communicate it, and a master node is responsible for delegating the containers onto the worker nodes, right? One is considered as a master node here team. The first one, you can see it. We can take 3 different instances, and one of which we're going to convert it as a master node, this one, right? And 2 of them are going to be a worker node 1, worker node 2. The worker nodes are responsible for running your application containers team, and the master node or a manager node is responsible for managing the containers. As we are talking about container management tool, so there is a guy called as a master within the cluster always, and that guy is responsible for managing the containers across the cluster. When I say cluster, that could be n number of worker nodes within the cluster that can be available always. Now that is how we need to create this cluster first of all. But how do I create again, right? We need to install the necessary tools for Kubernetes accordingly. First and foremost thing is that since Kubernetes is just a container management tool, it is just a container orchestration tool. Internally, it is going to use a containerization tool such as Docker. A Docker is mandatory, or without a Docker, Kubernetes is nothing. I can say it. Without a containerization tool, Kubernetes is useless. So Kubernetes internally uses something called as a containerization tool such as Docker to manage the containers which are created by the Docker. End of the day, Docker is the one which is going to create your containers, but Kubernetes is the one which is going to control these containers which are created across different Docker hosts within the cluster accordingly. So we're going to take 3 different system teams. We must install the Docker on every node. That is the first component that we need to install. Now, once you install the Docker, since we are trying to initialize a Kubernetes cluster, we must install the Kubernetes components such as Kubeadium is a utility or Cubelet is a utility that you need to install on every node again. We have to do this one. Now, wherever you want to initialize a master node team, whichever the node you want to convert it as a master node, right? That is where we run a command called as Kubeadium init. Means that team, this is the one which will let us create our cluster, or Kubeadium is a tool that helps to create the cluster or initialize the cluster accordingly. Means they're going to group it, or this tool will help us group this all servers together as a single system, and they will ensure that it will create a master node using a Kubeadium init. Now this becomes the master node, and it will also give you something called as a Kubeadium join command, so that this worker nodes will join the master node and they will start listening to the master. It is kind of a master slave architecture team. A master will be there, a slave is a worker node here. A slave always listens to the master, and then he will take the request from the master and do the necessary job on the worker node, or slave does one accordingly. Just like in anything called as a master slave architecture, the slave always obeys the master rules. Whatever master says, basically, it will obey for that. It will take the request, it will start creating a containers. If my master requests to create 10 containers, the worker nodes will create it accordingly, right? Now, this is the architecture team that you have it. Now, whenever you initialize these cluster, basically, there is a process that gets started, which is called as your kubelet. A kubelet is a process team that runs on every node in the cluster. Means this becomes, or this acts as an agent, basically, that acts as an agent which is responsible for your master and node communications within the cluster always. How does my master node able to communicate with the worker node? This is the process which is going to be responsible for listening to the master, and whenever the master communicates with it, it will talk to the kubelet agent that is running on every worker node. It will give the instruction to the kubelet. Kubelet internally talk to the Docker for creating the containers on my every node accordingly. Now this is how team you need to understand about it. This is how you need to understand about all these things. So KubeADM and Cubelet, this is the one you do it. Now, one final thing here, you understood about a KubeADM utility. You understood about a kubelet process that is going to run across the nodes. Now there is one more thing here. So far, if I want to create a container team, because containers are being created by the Docker directly here, we used a command line called as Docker, right? Whatever you say here, team, called as whenever you want to create, let's say that Docker run something that you say. Means that team, Docker is a command here which is helping you to create a container and which is managed by the Docker engine itself that you installed, right? But within the Kubernetes cluster team, within the Kubernetes cluster, because Kubernetes wants to manage these containers, Kubernetes itself gives a request to the Docker to create a containers. Docker does not create the containers directly here, which is managed by the Kubernetes now. Docker is also managed by the Kubernetes directly. So Docker takes the request from the Kubernetes to create the necessary container. So kubelet, or there is a command line utility which is given by the Kubernetes, which is called as kubectl. A kubectl is a command line utility, we call it. It means if I want to create a container within the Kubernetes cluster, I don't use the Docker command. If I use a Docker command, Kubernetes does not understand it. So in order for your Kubernetes to understand, Kubernetes must create it, or Kubernetes must request Docker to create something, then Kubernetes can manage that containers accordingly, right? Now that is where Kubernetes comes up with its own command line utility, which is called as kubectl. Kubectl is a command line utility of your Kubernetes cluster. Whenever you want to create a container within the cluster, you use a kubectl run. Instead of a Docker run, I use something called as kubectl run command. That is what I use it. Similarly, if I want to create or delete something, or if I want to update something, whatever you want to do within the cluster team, a kubectl is a client utility using which we can talk to the master or we can give instruction to the master. Now try to understand it here. Once we prepare the cluster like we had in Ansible controller, we just sit in the controller machine and we control everything on the target nodes. Here also team, we can sit simply on the master node, and master node is what where we give the instructions. We run a command on the master node that will be given to the master. Master takes that request and will start delegating. No matter what, how many containers you ask to create it from a single image or multiple images, whatever you want to do it, it will help you to do it accordingly. That is the architecture team of the cluster basically. Now this is how we need to prepare our cluster. Then we can start deploying our containers. This is called as a production grade cluster team. Within your production, if you want to maintain the high availability of your application, and if you want to get all the features to manage the containers well within the cluster, within the production environment, we must use this container production or container orchestration tools accordingly within your environments always. Now this is how team. So with this understanding team, I hope everybody is clear here. With this understanding, let's get into our practical mode again. Like we're going to create the cluster right now. We're going to create this cluster and we'll try to deploy the containers across the cluster. We're going to look at it accordingly. Okay, let's look into this one team. So how do I create the cluster first of all, and how do I do these things? So within the this one team, within the repository for you guys here, there is a Kubernetes folder which I've given. Within the Kubernetes folder, I have given a lot of information. What is Kubernetes, why Kubernetes, what is the Kubernetes architecture, everything, whatever we discussed so far, everything is available. You can go through this documentation too when you have some time. But within this one, we have something called as install. Within the install document, within the install, there is an instruction which I have given called install Ubuntu 18.04 LTS here. The step 1 is to do it, and a step 2, there must be step 2 here, and there must be step 3 here. We'll try to understand all these steps one by one. First of all, team, we need 3 machines here. I said like all machines, 1 should be the master node and 2 should be your worker nodes basically. So let's take them accordingly first of all. Now within this one team, you can see that I have created 3 different nodes basically. One thing I'm calling it as my master node or a manager node. The first one is called as a master node, as a manager node, and the second thing and third thing here it is called as a worker node 1 and a worker node 2. So I created 3 different servers team, 3 different servers. Now let's log into all of them. I think I already logged in here. Consider this one team. The yellow color text is your master node right now, where I already have the Docker running, I believe, right? Docker is available. Let's say that Docker PS. I have the container also. Let me remove this. Docker rm-f is a command to remove a container. remove this one. Now this is my master node team. I just have the Docker deployed here, or Docker is running for me. Now similarly, if I go to the worker node 1, here also team, the first and foremost thing is that you need to install the Docker. Let me validate it. So docker-v, you can see that the Docker installed on this machine also team. Let me go to the third one, which is going to be your worker node 2, docker-v. You can see that Docker is installed here also, which means that team, I have 3 different machines right now. One is going to be treated as a master node. The yellow color text you see, it is considered as a master node here. And there are 2 worker nodes that will be having it, where we will be delegating the containers to this particular thing according. Okay. So let's look into this one. Now let's create, or let's install things. We installed only Docker as of now. Like I told, we need to install the Kubernetes software as well, which is nothing but here. This is the one, right? So this is the instruction team which will install the Docker. This is what already been taken care, because we did it yesterday also. You could do the same thing on all the systems while installing the Docker. Now later team, I have this instruction which is called as your installing Kubernetes components such as Cubelet, Kubedium, and a kubectl components. This is what all we're going to install it to interact with the cluster and initialize the cluster accordingly. Now this is the instruction tree which I'm going to run it. As you see that the step 1, which is where on all the machines, which is master and all the nodes, like three nodes we have it, 3 different server, we need to run on all the nodes here. Now here it is team, I'm going to run this one. Now to be coming to the basics of Kubernetes team, and I think from where it is called as, Kubernetes is developed in a language called as Go language. Just for your information I'm giving you, Kubernetes is developed on a language called as Go language. Even Docker is also developed on a language called as Go language. Okay. Now, and also the Kubernetes is a product of Google basically. Kubernetes was developed by the Google organization, right? But it was used within the Google organization over a decade, from 2005 to 2014 something, for almost a decade. But they open sourced it. They gave it to a open source community within 2014. 2014, they donated this one to open source community, saying that for container orchestration, you could use this one. That is why they donated it. From 2014 onwards, it is an open source product, which is managed by an organization called as CNCF, right? CNCF is the official maintainer for this Kubernetes source code right now. The entire Kubernetes source code is available on the GitHub, which is a complete open source code. Open source, we call it. If you want to modify something, if you want to customize something, if you want to propose your changes to this one, you're most welcome to that one. Go ahead and then contribute towards this open source project if you wish to do it, right? So, but it is a product from the Google team. That is why we see that we are downloading the package from the packages.cloud.google.com. That is why you see that. So here it is. I'm just updating it. Now, once finally done, team, we are going to install the tools called as Cubelet, Kubedium, and kubectl components. Let's install them on all the nodes. First, we are installing only team. After installation only, we can initialize the cluster. Just installing the tools. They're all independent nodes as of now still. Once you install all of them, we will try to initialize the cluster. Once we initialize the cluster, that is going to be as cluster right now, like in the production environment. Then we can start deploying our containers into various worker nodes, sitting on only one node again, which is going to be our master node always. Okay. So I think we have installed successfully right now on all the nodes. Let me quickly check them. Right. Here it is team, it is good, I believe. Let's say that here team, I'm gonna run a validation, the simple validation whether installed versions are responding or not. Let's say that docker-v is a command to validate the Docker version. Now we install something called as Kubedium. Let's say that version is a command I can use it. O short, I'll say it. Let's say that this is a Kubernetes Kubedium version team that is installed, it is responding, which is good. Now there is something called as Cubelet that we install, which is called as this one, Cubelet -- version. Okay, Kubernetes version, this is also responding good for me. Now you can use something called as kubectl version, right? Version hyphen short, we call it, because this is a client utility team. This is called as client utility. We can see that hyphen client, we can see it. So this is a command team that to validate your commands. So you can see that the client version is also at the same. Means that team, we have installed our tools successfully right now. We have installed our tool successfully right now on all the three machines. You could validate the same thing on other two machines also, team. That will be there like this. So then once we installed these things, team, once we installed all these components, now that we need to initialize a master node, first of all, initialize a master node, convert this node as a master node. Once the master node is available, then we can go ahead and uh, join the worker nodes to the master. Likewise, team, you have an organization where there will be a manager always. A manager hires the team members to work under him, right? Now that is the same process here also. We can look at it accordingly. Now, in order to initialize team, in order to create a master node, we use a kubeadm utility. I can say that kubeadm init. Wherever you run this command, team, wherever you run this command, or in whatever the node you run this command, that node becomes a master node basically. Try to understand. Now this is going to throw some error thing. It says that the number of CPU available for your is one, basically is less than the required 2 CPU. Now team, the Kubernetes team is a little bit heavy component basically. In order to initialize Kubernetes, it requires at least 2 CPUs. But where you take the system called as T2 micro, where it is only one CPU will be available for you, right? But we can cheat this one, team. We can say that forget about these errors so that we can simply deploy the application on your T2 micro also. The same command, but I'll add a parameter here called as ignore pre-flight errors. Just add this command, team, so that it will ignore that error that you are getting it. This is that all I'm doing it. So this is equals to all, that is what you give it. Now you can simply ignore whatever the error that I'm getting it and proceed with the installation or initialization of the master so that you could use your free tier instance system. If I want to procure more resources on AWS, that will charge you. So try to avoid that. You can create the same cluster using your T2 micro also, but just provide this parameter at the end. That is all you're going to do. Okay. Now you can initialize this one. It is going to take a couple of minutes to initialize your server team. Now, Kubernetes master node is also known as a control plane team, just a terminology wise, I'm telling it, because whenever it says it is going to initialize this one accordingly. We look into it, it is going to take some time. Now, this is how team you can understand it. Now, the second step team, this is what we're trying to do it right now. Let's say that kubeadm init, and this is, you can avoid team, this is not necessary actually. Like I did not do anything, you can avoid this completely here, right? And you could also install team. I'll tell you what exactly we're going to do it. Let's say that this is the command that I'm using it after we initial. This is once this is successful team, we can use this one accordingly. So here it is. It is still doing it something. Let it complete it. Now, once we complete this one, once we initialize the master successfully, we need to take care of a few steps. You can see that team, it says that your Kubernetes control plane has initialized successfully. The control plane has initialized, which means that the master node has initialized successfully. But it says that to start using your cluster, you need to run the following as a regular user. You can even run them as a root user or team. Doesn't matter with which user you run it. But it says that you need to run these commands. Right? These are the three commands we're giving you. I think these are the same instruction. I kept it here also, team. The same instruction. You could use it from here or from there. That's fine. Whatever it is. I'll copy this instruction from here itself. Go to the master node and then run these things, right? Now, these are the three instructions team that I have ran it successfully right now, right? Once you run this instruction team, let's say that a command called as kubectl get nodes, I'll use it to see that overall part of the cluster. Now you see that team, there is something called as, there is one node it is displaying for you, which is called as a master node. The role of the node is called as master node, and it says that the status is not ready. Now, why the status is not ready, team, if you try to understand, the whole purpose of your container orchestration tool, also one of the major reason we are creating this one is why, because, right, it provides the communication, right, or enables the communication across containers or multiple containers running across multiple servers. Now, how it is going to do is that, team, it is going to install, or we must install a networking solution basically. We must install a networking solution, right? By default, it does not come up anything, but it is going to set up it a default networking driver that you need to install it. That is called as the second step. It is telling you, team, here we must install something called as, you should now deploy a pod network to the cluster. Means if you don't deploy a networking driver that is responsible for the communication of multiple containers running across multiple servers, that you need to install it accordingly, right? And that is why team, we must install any solution here. Likewise team, Kubernetes has many networking solutions. I'm telling you, Kubernetes has many networking solutions. You can go to an official documentation, right? You can go to official documentation of this one, where it will talk about many of the networking solutions that you can install. This is official Kubernetes documentation team. We are creating this one, single control plane with a kubeadm. This is what we are doing it actually. So here it is. If you go below team, it is give you all the instructions according to your requirement. But in the below, where you have to install a pod network solution, right? It will give you various options basically. Let me show you that. I think we have crossed that section already. Where is this? So it's saying install a pod networking add-on here. That is what we do it. So you must deploy this container networking interface something. Where exactly this one, right? Add-on.yml. This is where team you must use it. Where is this? So let's look at this one team. Where are the various solutions? I think this is not giving any documentation. Okay, fine. Now there are you need to get the documentation team. There is multiple things will be available. So we're just looking at these ones. So there is nothing here. Okay, great. So there is anyway team. The instruction is available here, which you need to look into it. Wait a second, team. I'll just look into this one. I just mentioning this one. I'm just looking for the networking solution thing. This is what is doing it. We must install this one. I have it within my instruction also, but I just want to use a different one here. That's what I'm just looking at. Just give me a second, team. We're going to do this one. Let me get this one. Installation of installing kubeadm. Okay. Well, this will have it. Here it is, team. Here it is. You can see that when I'm talking about this one, team, you can install one pod network cluster. This is what it is I'm talking about it. Now this is where team, as I was talking about it. So there are many networking vendors we have it, or many networking solutions we have it actually. Now like Calico is one of the one, Cilium is one of the one, or ViewNet is one of the one. You can choose any of these networking solutions team as per your wish. Right here it is giving you like how do you deploy this one. You can simply use this command to run this one. I'm going to update the instruction sheet. Don't worry, this is what it is. I'm doing it right now. We are installing a solution called as ViewNet. This is responsible for the container communication team across the cluster. So let's deploy this one also within the cluster right now. Now, once you deploy team, whenever you deploy this networking solution, then only your cluster will be in a ready state. That is when it is going to be in a ready state actually. Let's wait for a submit time. Okay, it will get nodes. It may take a couple of minutes to initialize the node team. This is how you need to ensure that your master gets initialized. First of all, ensure that your master is up and running. Then we can go ahead and join the worker nodes to the master accordingly, right? Let's say that. Now you can see that team, the master is ready as it is initialized successfully right now. Now you see that the master components is ready and master is up and running for me successfully right now. Now, once you have this one team, we can go ahead and join the worker nodes here. Now, if you look at this output team here, it says that now we did this one team. There are two things to start using cluster, run these commands. This is we done. And we deployed our pod network solution. This is another container network solution for container communication across the cluster. Now, there is one last thing. It is in that then you can join any number of worker nodes by running the following run as each as a root user on every worker node. Here it is giving you something called as kubeadm join command team. Within the join command, here it is giving you something called as a master IP address and a master port number where the master will be listening to you. Now you can simply use this, take this command, right? Go to the worker node, and you can simply run it. It is going to join this worker node to the master accordingly, right? You can see that team that this node has joined the cluster. That's what the message you get it. Now, once you this one, go to the third node also and join this one. Simply run this one. So here that this node has also joined the cluster team. Now, once you joined this one team, now this is the single cluster which has multiple worker nodes in it. Now you can go ahead and get the worker nodes command here. Now you can see that team. There are two nodes coming up here. One is called as master node, and the none role is nothing but your worker nodes team. They are all called as worker nodes basically. Simply look at this. Now you have this one. It is not ready yet. It is going to be ready within a minute. It is taking a minute team. Let's get it ready. If it is not getting ready, we must troubleshoot what are the issues that you have it with that node. Maybe we can see that upon. Now it is still not ready team. It is not getting ready. Maybe some issue on the node. We must troubleshoot it. Let me wait for a minute. Now it is not getting ready. It might have done by this time team. Let me look at it. What exactly is the problem here? You can use a command called as kubectl describe. I want to know about the node why it is not getting ready team. Just say the describe command node and the node name you can give it simply. This is what the node name you can give it. Now you can see that there would be some issues. It will be telling it. Okay, now it says that node is ready now. And it is saving that. I think we should have waited for one more minute there. Get nodes. Now you see that it is ready team. Means that it took some time to initialize the node basically. That's how it will be done. Once the nodes are initialized team, now you can see that we have created our cluster successfully. We have one master node and then we have two worker nodes within the cluster. Now with this understanding team, we need to understand now how do I create my multiple containers or single container within the cluster, which should be delegated, or master is responsible for now delegating the containers onto the worker nodes always. That is the default behavior of your cluster always. Master node is dedicated for the container management across the cluster members, right? And then it is going to delegate the work to the worker nodes, and it is going to manage the worker nodes completely. Whatever you want to do it, you will do it according to your requirement. Okay. Now here team, once we have the cluster is initialized successfully, now we must understand that how do I deploy a container, a single container maybe, or multiple containers from a single image or multiple images, whatever you want to do it. We will try to understand that one team accordingly. Let's look into this, right? So here it is team. Once you have this one, we can run a simple command called as kubectl get pods. Now team, terminology wise, this will be a little bit different terminology here again. Within the Kubernetes cluster, a container is called as a pod, which means that team, whenever I say that I'm creating a container, I say that I create a pod here. Now let me tell you again why it is called pod again. It is a long concept, so you don't worry about it. Now within the Kubernetes cluster team, whenever I say pod, a pod is nothing but your container only. Okay, so this is what you can think about it. Whenever I say that I use an image to create a container with a Docker, we call it, but within the Kubernetes, we say that container is nothing but a pod, which means that whenever I say I'm creating a container, I say that I'm creating a pod within the cluster here. So why it is again, Kubernetes has different terminology that has its own terminology to use it. That is what we call it according, right? So here team, consider that within your knowledge right now, whatever you have it, whenever I say pod, which means that I'm creating a container, right? From an image given, we're going to create a container. We're going to create multiple containers from a given image, multiple pods also the same thing, right? That is what you need to understand. So here it is team. So let's come back to the cluster here. And if I want to create a pod team, nothing but I say that I'm saying that kubectl get pods right now means that there are no pods or no containers running within my cluster. Within my cluster, there are no pods or no containers running it. Now I need to start creating my containers within the cluster. Let's say that I'm going to use a simple command team here called as kubectl run. Just like your Docker run team, we're going to use something called as kubectl run, and you must name your container here. Like there, the random names were generated for the containers automatically, but here, which is going to give a name called as, let's say that my pod I call it, or my container, what do you call it? My pod is something which I'm calling it, and the image I want to use it for this is called as ---- image is equals to the same image team, whatever we used it. Let's say that we built an image just now and we upload it to the Docker Hub. Let's get it and run it, right? Let's say that learn DevOps, right? The sample app du, this is what the image we pushed it. And this is the same image team. Just now we build it and we push it. That's the same image I'm getting it here. Now by default team, you do not need to mention a detached mode here because Kubernetes by default runs every container in detached mode only. That is what it is doing it. Let's say that here, this is the simple command team to create a container or which is called as pod here, right? And this is what I'm doing it. Now it says that a pod, my pod created. It is simple messaging which says that it is created. Now if I want to list the containers, list the pods within the cluster, kubectl get pods is the one which I'm using, right? It says that within this one, it is container still creating for me, means it might be downloading the image. It might be taking some time for you to create a container accordingly, right? So here it is. Now you can see that it is in a status called as running, right? See that this is a container rating called as pod here. My pod is what I'm calling it. Now, if I want to create multiple pods team, I must run multiple this one accordingly again. So this is how team you can understand about Kubernetes here, like how do I create a cluster, right? And how do I start running my pod within the Kubernetes cluster accordingly, right? Now this is where team look at this one. My pod is running successfully. But the question is that here, where is this pod is running? Is it running on my master node or is it running on a worker node, right? But the purpose of a cluster is that it is always supposed to run on the worker node itself. Now, how do I validate is that you can simply use a command team kubectl get pods -provide, right? You see that now it is running on something called as this one, right? This is the node basically where it is running. What is this node basically? If you look at it, kubectl get nodes, right? Get nodes. You can see that team, this is running your master node is 69 team. The host name of your master is this 169, but it is running on a node called as 194, which means that this is the node, this is a worker node, right? Means that master was able to delegate this container onto the worker node automatically. That is what all you need to understand here. kubectl get, or you can use something called as describe also. kubectl describe pod and the pod name, whatever the pod name you have given, right? Let's say that this is what it is. Now you can see that within this one, you see a lot of information about it. It's just like a Docker inspect all there. Here it is, right? Now here it is, team. What is the name of the pod and what node it is running it, what time it is created, what are the labels it is using it, what is the IP address of your containers here? This is nothing but, and the containers team have it container ID again. Similar to that one, just like the Docker is only just creating, so Docker container ID will be still present, and the image that you use to create a container. Are there any ports exposed in as of now here? We did not expose any port, which means that we will not be able to access this application team. We will not be able to access application. This is what you do it. And similarly, team, if you see this below, there are various features coming into the picture. Let's say that scheduled, something it says that it is scheduled to the worker node accordingly, and it's trying to pull the image. So to pull the image, created a container, and this is what it is doing. Now, this is how Team Kubernetes gives you the information about it. This is all what you need to understand. How do I create a pod? Nothing but a container within the Kubernetes cluster accordingly, right? Now, this is how team you can simply understand about how do I create a single pod. But the purpose is that team we understood again, how do I create multiple pods from a single image, right? Multiple containers from a single image is a question, right? Now we need to look at various features of your Kubernetes cluster also. That's all we need to understand, team. That's all we need to understand here. Now, first of all, team, let's try to understand about a pod itself, because pod concept is a little bit different than your container concept. Of course, it is a container only, I told it. But what exactly is a pod, team? If you try to understand it technically, why Kubernetes is calling it as a pod instead of a container, right? You must understand that. Okay. Let's try to look into that one, team. So let's say that here I said pod is equals to container. That's absolutely correct, right? But why it is called as pod, right? Now earlier team, we say that we are actually creating an image with something called as an application, right? Do not size, let's make reduce this. Okay, now this is have it in. Now within the image or within the container, you always have an application. Let's say that Tomcat will be there and you have Java, then you have OS library. This is the content of your image team. Now this is also called as your container, means the image is converted as a container. That is what it is doing it upon, right? But why we call it as a pod within the Kubernetes here? That is what all you need to understand, team. Try to understand, team, within the Docker world, whenever you created a container, Container has a networking IP address, means that container itself is managing the network for you, right? Container also managing the storage, which means that whatever the data generated by the container, which is within the container again, which is also managed by the container itself. So container itself is doing multiple responsibilities here, team. It is running the application. It is controlling the network to access the application. It is also controlling the storage to provide the necessary storage for your container accordingly, the application accordingly. There are multiple roles which are done by your container here, so which is kind of putting a heavy load on your container architecture. And that is why team Kubernetes has simplified this a little bit, and they say that okay, instead of doing everything to the container, let's say that let me hire a manager for it, or let me hire a manager, kind of this one. There is an abstraction layer that will be available for you. There's an abstraction layer, we call it. Now within this one team, they say that container runs within a pod, we call it. Don't confuse yourself, team. Container runs within a pod, we call it. But Kubernetes provides a set of resources to the container. Container is dedicated now to run only the application. Within the container, you just have an application that runs your application. That's it. That is the only responsibility of your container within a pod. Right? Whereas the network, which is required by the application here, network namespace, what I call it, means IP address to access your application, which is held by your pod again. The pod holds the IP address here. A pod gets an IP address, right? So this is what you can see on network, and the storage component also. Let's say that my application requires some storage space on the disk also. Let's say that a volume maybe. We haven't discussed that concept, but I'm just saying that if it requires storage, a storage also provided by the pod layer. Now this is how team we can think that a pod is an abstraction layer, which is kind of a manager for your container, which gives a set of resources for your container and manages the container within it accordingly, right? A pod manages the container within a team always. A pod manages the container within it, or pod governs the container within its within inside it, whatever is inside it. So it provides a set of resources for your container, which is required by container. In a production scenario, you always have this structure, so that let's say that if I want to create 10 containers, now I say that I'm creating 10 pods, right? That is what are we doing it. Now this is the concept of a pod team. To be technically discussing again, this is called as a concept of a pod. Basically, a pod is abstraction layer on top of a container. This abstraction layer is kind of a manager for managing the containers within the pod, inside the pod basically. Now team, you may ask me, like, since it's an abstraction layer, Naresh, can I create multiple containers within a pod? Can I run multiple containers within a pod? Because if I have a bigger box, I can put multiple smaller boxes within it, right? Definitely you can do that. So similarly, a pod can run multiple containers also within inside it, but we never run. Okay, I'm telling you openly, you never run two containers within a pod, but pod is capable of running multiple containers within it. If required, team, in some cases where your application, there are two different applications which requires the same network identity and storage identity. In such cases, we can run two different applications within a single pod. But again, we never do that in a production scenario. In a production scenario, you see 99.99% only the single container pods. That is what all we're gonna do it. Okay. So this is how we can understand about a pod basically. A pod is an abstraction layer which runs outline, it's outer layer of your container basically, which provides a set of resources for your container upon it, right? And this is what you need to understand about a pod concept within the Kubernetes. Now Kubernetes can manage the pods team, but it cannot manage the containers within it. Kubernetes knows how to manage the pods, which means that if I have to create 10 instances of my application, then I must create 10 pods for my application accordingly. That's what Kubernetes suggests you to do it. So which means that in here again, like I'm telling here, let's say that, just give me a second here. Let's start the network, which is there, and then the storage, right, which is within the container. This is what it is. Now let's say that this is what I'm calling it, is called as pod, right? Now within the Kubernetes cluster team, if I want to create multiple application of mine now, I will create multiple pods, right? Multiple pods, which is what I do it, is that multiple pods will be running within the Kubernetes cluster. Now Kubernetes master or Kubernetes manager node, it can manage these multiple pods accordingly, right? This is what we're going to do it. This is how it will be there accordingly. Every pod will have its own IP address to access it. Like you have this one, and we can access the application from each pod accordingly. Now, question is that team, so far we created a pod called as a single pod, right? Single pod is what we created here. kubectl get pods is what I'm saying it. Now I created only single pod. Now that is the reason team here you see that one by one, which means that within a pod there is only a single container running for you. Now that is the reason you see that one by one. If you run two containers within a pod, now it will become a 2 by 2, or if runs there are two containers within pod but only runs one by 2 it shows it. The right hand is the number of containers within a pod. The left side is that how many containers are successfully up and running within the container of pod, within the pod accordingly. That is one. Now this is how team you can understand about it, but let's look into this one simple thing here one more time. How do I create multiple pods? That is what is something team. Now team, a single pod is a single pod team. It is an independent pod basically, which is not controlled by everybody or anybody again. Means that it does not process any features within the Kubernetes, right? If I want to create multiple pods team, now we say that we hire another manager here. That is called as your deployment or controller. We call it a controller team we created within the Kubernetes. Now we're gonna create something called as a controller. We created a pod just now, right? We're going to create something called as controller. What is a controller team here? Controller, right? Controls or manages, we call it, set of pods from a single image, right? This is what is called as a controller definition team, we call it. Means that it's just like understand that just like hiring another manager to manage multiple pods from a single image. That is what all we're going to do it. Simple words. We created a single pod that is of no use for me anyway. In a production scenario, again, we have to create multiple instances. Now this controller will help me to create multiple pods or scale up my number of pods according to my requirement within a Kubernetes cluster account. This is waiting. We're going to create a controller now. That controller is called as your deployment controller. There are various types of controller we have it within a Kubernetes, but we're going to look at something called as a deployment controller, right? Which provides the necessary features what we are looking for so far. That is what we're going to create. Say here, if I want to create a deployment team, if I want to create a deployment controller, now I'll say that kubectl create. Instead of run team, a run will always create a single pod for me. If I want to create a deployment, which can let me create multiple instances, kubectl create deployment, I'll call it. Now you must give a deployment name here. Let's say that this is my deployment, right? And you must provide the image from which you want to create a set of pods. Let's say that image is equals to whatever the image that you want to give it to, you can give it. Let's say that I'm giving a separate image here, which is called as learn DevOps / sample py app v1. Whatever the image team you want to give it, you can download it and give it that image for me. This is another image from my Docker Hub account, which is a sample Python application, I call it. Sample py app, I'll call it. The version 1 is what I'm deploying, right? Now this is how team we can give it, but right now team, I did not mention how many replicas I wanted or how many instances of I want for this application. If you do not mention the number of replicas or number of instances you don't want it, it will going to create a single instance again for you. It is going to create a single instance only for you. Let me show you that. So in order to get the pods team, of course, it is going to create a pods only, but we created a superset object here, which is called as deployment. So the kubectl get deployment is what I'm telling it. If I say get deployment, it says that, okay, you requested one pod and up to date are one and available is also one, right? That is what we did not mention how many we wanted. So it default considered as a single pod is what you want. But this pod is controlled by something called as a deployment controller team. Earlier pod was an individual pod, kubectl get pods if I do it. This is also running a pod. This is also an application pod which is running it absolutely. But this is an independent pod which is not managed by everybody. Like, you know, this is kind of an individual contributor. You have it within your organization. That is why it is not, he is not controlled by anybody there except that which is managed by the master here. That's it. But this deployment, this pod team is managed by a deployment pod as your my deployment. Now, what is the difference between these two teams? If you try to understand it, if I delete individual pod, kubectl delete pod, this one this may not come back for me, right? This may not come back for me. He is gone. Nobody worries about him. Nobody takes care about this one. This is what is one. This is gone. That is what happened. But if I delete a pod which is controlled by a controller, now the controller ensures that okay, he is always available again, which is called as auto healing team, which is going to be called as auto healing here. So here team, it is going to have a 30 seconds is a grace period to delete the pod. It is why it is waiting for 30 seconds. 30 seconds is the default grace period before it deletes anything within a Kubernetes cluster. So it is trying to do that one here. Now it is done after 30 seconds. Now team, you see that kubectl get pods. See this basically. Now that pod is gone team. It is never come back again. If it is an independent pod, it will never come back. But let's say that if this is a pod, this is also a pod team which is controlled by the deployment controller. Now let me delete this pod basically. kubectl delete pod. Now let's say that this is the one. If I do it, now this pod gets deleted, but as soon as it is deleted, team, a manager or this controller identifies that okay, you deleted it, but I have to run. But the controller duty is to maintain that desired state always. At least that I need to maintain this view already. Let me recreate your pod, right? Get pods here. You see that it is recreated again. Auto. This is called as auto healing feature, team. This is called as your auto healing feature. A pod which is controlled by a controller will always be created automatically again. If you want to delete the pod here, you must delete the controller itself so that it will delete the pods accordingly again here, right? Now this is how team you can understand about it. But there is another feature here right now, kubectl get deployment. I'll get it. Now this is where team you can scale it up. Now if I say that the same image, I want to create multiple instances. How do I do that? I can use a single command called as here kubectl, right? Uh, kubectl, just give me a second. kubectl scale is a command, you can use it. kubectl scale, right? Deployment, right? And then scaling up, team, scaling up or scaling down, you can do it. Scale deployment called as my deployment. Now you can ask the number of replicas you want to create. Let's say that hyphen replicas, and I can see that simply 8 or 10 or 100, whatever the number you wanted, you can ask it. Now it is going to create those many pods or containers for you accordingly within the cluster, and they're all will be delegated to all the worker node team. I'll show you them. This is that kubectl get pods right now. It is going to create 8 pods for me. You can see that there are 8 pods are created automatically with a single command for me. Even if I request 100 also, it is going to create 100 containers for me or 100 pods automatically, right? But where are they running team? They will be scheduled across all the worker nodes in the cluster. See that there are 2 worker nodes you have it. So 194 is a worker node and 173 is a worker node. See that they're all equally distributed. 4 pods on your 194 and 173 running of 4 pods basically. So it is always that master delegates the work onto multiple worker nodes so that you will get the high availability always again. It will never deploy into a single worker node team. Master will ensure that even if I reduce now, even if I reduce down to 2 pods, right? Let's say that from 8, I want to reduce it back to 2. This is how you reduce them. Scale out is we did. We can scale down also now. Let's say that I want to delete 6. I want to keep only 2 pods for me. Let's say that 2. When I say 2 team, it is going to delete all the other pods here. Let's say that kubectl get pods. I'll do it. See that it is trying to terminate everything, whatever is not necessary here. Right here, if I see that kubectl get pods hyphen o wide, you can see that it is trying to delegate it onto both are running on a single node right now. That is how it do it. Now it takes care of the decision team accordingly at the runtime basically, right? Now this is how team we can understand about it. How does a Kubernetes help you to scale out and scale down as per your wish? And it is also providing you a feature called your auto healing feature by default. That is how you can understand about it accordingly, right? Now let's say that I'm going to scale it up again a little bit more. Let's say that 4 is what I'll give it. I can do this as many times as you want it. You do not need to deploy it again and again. You don't need to remember anything. Kubernetes give you these simple commands to scale it out and scale it down. However you want to do it, you can simply do them according to your requirement. You can see that now there are 2 on 173 and 2 on 194. It is deployed again. They are all up and running for you accordingly. Now this is how team you can understand about it. How do I create multiple containers or multiple pods within a Kubernetes cluster with a single image? You can create it as a deployment controller. A deployment controller possesses some set of features such as auto healing and a scaling feature, like it can give you the scaling out feature or scaling down feature automatically, right? Now this is how team you can understand about a deployment controller within the Kubernetes through which we always deploy our application within the cluster accordingly, right? Now this is how team, this is called as a command line way team again, but in a real time, we must write a YAML file for it. I'm telling you that this is not a recommended approach to write, deploy your controllers. We must write a YAML file for deploying any set of applications within a Kubernetes cluster. Now, how do I write my YAML file team again? I'll just quickly walk you through like how do I write a Kubernetes YAML file and how do I deploy the same thing with a Kubernetes YAML file. Or before that team, before that, let's try to understand that how do I access my application? Then we'll jump onto the YAML part that is called as a declarative model. For even creating a single pod, we can write a YAML file. For creating a complete deployment, we can write a YAML file, right? For even creating something called a service that we're going to discuss now, for which also we can create a YAML file accordingly, right? Now let me show you that one team. So first of all, let's try to understand that how do I access the application now, which is running within this pod, right? There are 4 containers running for me now. How do I access application running within this? Each instance is running the same application team because this is a single image we used it. A single image is always about a single application that we do it, right? So within this image right now, the 4 instances are having the same application, which is going to be accessed. How do I access my application running within this Kubernetes cluster, right? Now this is where team, you can create something called as a service, right? A service is responsible for sending a request into the backend pods accordingly. A service is going to act as an internal load balancer team. I'm telling you, this is another beautiful feature of your container orchestration, which will help you to manage the containers in the production accordingly, right? So here team, if I want to access these pods, I say that I must create a service. Like in the Docker world team, we just created -p option. Whenever I want to access my application, we just use something called as -P option, which published a port number on the Docker host, right? Then only you are able to access application. Now here also team, within the container, there is a port number available already. Within the port number or within the Docker image, you have the port number. Let's say that this is running on this container team. Let's say that here all Docker images, I'll do it just to show you the images team. This is image called as this is one, right? This is what we're running it right now. So sample py app. If I want to know the port number for this application team, this application, I can use something called as, I told you yesterday also this command for somebody asked me, like you can see that docker inspect, right? And then you can give the image name just to show that one team. I know that we can do it. See this one, this is the information about this image basically, right? Within which you would understand that what is the port number that would run it within this one. We will see some information here. This is a Python based application, right? Now you would see something called as within this one team, it is going to run on a port number called as 3000, which means that within the container or within the pod basically right now, the port number is 3000, but outside the container where exactly I want to host it, which means that team here, try to understand this. Here, instead of this Python application, right? Let's say that I'm running a Tomcat application, I'm running a Python application. So here it is. I have created a set of pods here. This is my pod. Try to understand, right? So within this one, I'm running a container, right? I'm running a container within a pod. This is where you're running something called as an application called as Python team. It is not a normal Java application, but it is a Python application. That py app is something I'm running it within this one. Now I install a Python 2.7 or something, whatever it may be, and there is something called as OS. Now this is what it is team, and within this one, the Python application is listening on a port number called as 3000. This is how team you can have it. This is what is having it here. Now this is what is called as your pod. Likewise team, we are running 4 of these pods, right? 4 of these pods are running within my cluster wherever they are running. So you can understand that this is what it is. There are 4 pods that are running within my cluster right now, like this, right? But if I want, let's say that team, these 2 pods are running on 2 different hosts right now. two different Docker Kubernetes worker nodes, we call it. Let's say that this is what is a worker node, right? Now the first two pods are running on a single node team, right? This is a single node where you have something, all the tools are installed. Now that these two parts are running on a different node like this, right? And this is another worker node where they are running it, right? Now this is how team you have your pods running across your cluster. This is called as your worker node 1 and then worker node 2, right? Worker node 1 and this is called as your worker node 2, right? This is all you have it. This is how you're running your pods team within the worker nodes accordingly. Now, if I want to access this one team again, I must expose a node port actually. I must expose a node port again. Likewise, use a capital P and then you must, a port should be available here for me. Let's say that's something like 32678, something like that. This should be available across the cluster again, somewhere every host. Now, then I can access application team. Now, how do I expose this, right? That is where team, we can create something called as a service. Is that kubectl get deployment, I'm calling it in. So we can expose this deployment as a service team, which means that kubectl expose, I'll call it deployment, right? Kubectl expose deployment and the deployment name you're seeing it, right? And you must mention the port number of your container, whatever the port number, which is 3000, your container port number. And you say that I want to expose it as a node port service, which means that a node port is what I wanted. This is what the syntax that goes to. Now this is how we can simply expose this particular service. Create this one. Now it says that service my deploy is exposed right now. Now if I want to this see particular service team, which I say that kubectl get svc, a service we call it, or you can give the service basically. When you see this service, basically there is something called as a my deploy service which created a type called as node port service. Now you have a port number called as 31946. From the browser team you can access this IP address accordingly, right? Now let's say that here I'll go and get my worker node IP address, right? Now I can go here, right? I can go here, I can hit that port number which is exposed on my node, which is 31946, some random port number which is given. 31946 is what I'm going to do. Now you can see that team application response here. Now the beautiful feature of this service is that team, the service is responsible for sending the request into all the backends, which is nothing but it is going to act as an internal load balancer for me, which will forward the request into all the backend 4 pods. Wherever they are running team, it doesn't matter. Kubernetes takes care of it running or routing the request into all the backend pods accordingly. Just to prove you that team, this is my pod name. If you look at it, look at this one team. This is called as a pod name basically. kubectl get pods if I do it. So this is where team you have this one, a pod name. This is the first pod name, second pod name, and third pod name. If you keep on accessing this application team right now, look at that, you will get a different pod IP names here. You can see that this is NN right now. Here it is NN, the third pod within the line. If I look at it, N2, that is a different one, second pod it went to, right? Look at this one, it will keep on rotating the request team. Means whenever I'm hitting the same URL team here, it is requested is routed to the backend pods automatically, which means that Kubernetes service is acting as an internal load balancer for you, which is helping you to forward the request back to all the backend pods, right? Application running across all the backend containers team. That is the feature again, you get it. This is an internal load balancer which is created by the Kubernetes automatically for you, which will help you to route the request into all the backend pods, whatever you want. I can see that it went to this one. It is keep on doing. Sometimes a sticky session comes under the picture here. So you can this one. Likewise, team, you can understand that a Kubernetes service, you can expose it. You can expose the service as something, and you can access your application from the browser. And this is going to forward the request back to all the backend pods automatically. That is the default behavior of your Kubernetes cluster again. This is what all you need to understand. This is what all you need to understand here. Now this is how team you can understand about how do I create something within a Kubernetes cluster, like create a single pod, which is of no use of course, but you can do that one for just for practice purposes. But in a real-time production scenario, we always create something called as controller, such as a deployment controller is what we created, which will help me to scale out a number of instances I want it always. This is called as manual scaling, but this also supports something called as auto scaling also. Now it also provides something called as auto healing. Auto healing is what we do it, right? And it also provides, like, whenever you create it, we have create a service. The service will help you to manage the request flowing into all the parts in the backend. That is how Team Kubernetes help you to do it. So this is all about on the top level team. On the top end, how does Kubernetes works you for the cluster level? All the cluster members are active always, and they will help you to deploy the containers across the cluster members so that you could achieve the high availability of your cluster accordingly, right? Or high availability for your application within a Kubernetes cluster accordingly. One thing here, team, as I told, like, we are not really, doing the command like commands like kubectl create deployment, kubectl expose something, right? Instead of this one, team, we must write a YAML file always. Writing a YAML file is necessary, team, in a Kubernetes always. But there is a beautiful feature of your Kubernetes which allows you to generate the YAML file and then use the YAML file for definitions accordingly. If you don't know how to write it, YAML rules, team, that we discussed yesterday for Ansible, YAML rules remain same thing. Only thing is that it will change some keywords here. The keywords is what you need to understand, but Kubernetes will allow you to generate the YAML files automatically. So we will generate a YAML file, we'll try to modify them accordingly as per the requirement defining. Now let me show you, team, how do I generate a YAML file. For a single pod, first of all, I'll do it. Let's say that kubectl, right? This is the command I was using it, kubectl run, and your pod name such as my pod, and you must see that image name, image is equals to whatever the image, let's say that nginx image I'm using it. Now, if I want to see this thing, if I show this one, basically it is going to create the pod, but I don't know how to create the pod. I just want to do a dry run. Let's say that dry run is a command I use it, is equals to client, I'll call it. Now let's say that give me a YAML output for this one dry run. Now -o is something to output a YAML syntax for me. If I do this one, I'll simply get the YAML file here. Use this YAML file again, right? There are separate keywords here that you need to understand. A kind pod, what exactly you're creating it, what are the labels here, what is the spec containers about it, everything it is in regular context. Now you can simply use this YAML file, team, to understand all the things. Similarly, we can create a YAML file for my deployment also, right? Let's say that kubectl create, right? Deployment, I'll call it, and the deployment name, whatever the deployment name that you use it, my deployment, right? Whatever you case, my deployment or something. Now, once you have this one, team, again image, and then see the same thing here. This is going to generate a YAML file for your deployment structure. Let's say that a kind is deployment here, and the API version is something different, and metadata about it. And the spec here, it is giving you, team, by default one replica. Means if I want to create this one, I can simply take this, whatever the output I get it here, it's that vi my deployment dot yml, I'll call it. Open this one, enter this one, and you could modify the values, team, here, whatever you want it. Let's say that instead of one replica, I want to create 6 replicas here, and then you can change anything. Image, if you want to change it, change the image name, whatever the image that you want to change it to, you can change it. Let's say that here I want to run a general Tomcat image, right? This is how you can simply do it. Simply run this command, right? Save it. Now, once you have a YAML file, team, once you have a YAML file here, you could create your things using a YAML file like this, kubectl create, right? Instead of run or create deployment, you can say kubectl create -f and give the deployment. Yeah, that's all you're going to do it. Now, this is going to be created from the YAML file as per your request according, right? kubectl get, right, deployments again. Look at it. Now you can see that there are 2 deployments running. For my deployment, there are 3 out of 6 are ready right now. It is going to make it all of them ready. See that there are getting ready, right? It is taking some time, team. It is taking some time. If you want to check the pods, team, let's say that kubectl get pods. See that there are all the pods are running. There are 6 pods for this is running it, and 4 pods for my this application is running, right? A different type of applications runs a different type of services, everything, right? And you can access your applications, which are running within these pods accordingly by exposing them as a services. By exposing them as a services, basically, that's what it is. We're gonna do it. Okay. So this is how, team, you can run a containers within a Kubernetes cluster, right? A single container or a single pod, we call it, or multiple pods using a deployment controller. which will help you to do a various steps accordingly. If you want to access it, you must create a service for it. For a service also, we can generate a YAML file team, kubectl expose, right? So whatever you said, kubectl expose, whatever you said, expose deployment, right? And deployment name is called as my deployment, right? And you could name the service hyphen name my SVC, right? Right. And let's say that here hyphen um, the port number team hyphen port that you give it, so that something called as 8080, and let's say that hyphen type, right? Type is equals to node port, and let's say that I want to generate this one as client run, right? Is equals to client hyphen OYAML, right? This is how you can simply give it. Now this is also going to generate a YAML file for your service, kind service, and whatever it is you want it. If that is structure team, you don't need to worry about the structure. Also, is going to order everything in a structured format already. You must understand team where you need to use these values accordingly, and just use this one according to your requirement. So this is all team you can understand about it. This is all you can understand. Now, one last example team, I would like to show you a realistic example, like a realistic application that you would deploy it within your Kubernetes cluster. Let's say that there is an application which is available and that will have an access to the database. A database will write data to the persistent storage. Even if I lose my database container, like somebody was asking me yesterday, I believe, to show an example where it will show a realistic application which access the database, and database will be written to a persistent disk. Even if I lose the database container, whenever I create a database container back again, it should get the data again. That is the scenario team. For example, that is also have it. Before that one, let me show you first of all kubectl get deployment. Let's delete this one team because we are running too many pods here. That would crash your system with the minimum capacity of system we're using it. Let me delete these things. Kubectl delete, right? Deployment, right? And you can give the deployment name team here, which is going to delete all the pods behind it. Let's say that my deployment can give multiple deployments also like this, right? kubectl, what happened here? Okay, the spelling mistake team. I'm sorry here. This is deployment. Now I can see that both the deployments got deleted, which means that internally it is going to delete both the deployments for you. Get deployment. Now there are nothing available here, so we can do this once accordingly, right? Now let's say that team, I'm going to create a realistic application. The application would access my database, and the database will have a persistent data to it. Of course, this is a bigger YAML file again. We're going to create everything within the YAML file itself. The example is available within your repository, which we shared with you. So let's look into this one. Go here. There is a folder called as Cube. Now, whatever we discussed, team, everything is available within this one. Services, pods, controllers, everything is available here for you. Just go through them accordingly. But if it's in the controllers, I have a YAML file called as myapp.yml file. Let me take this content team, everything. This is a bigger YAML file team, which is having all the things, multiple things within things basically. Not this one. Let's go back here, right? So let's say that we are myapp.yml, right? So here it is, team. Try to understand this. This is a bigger YAML file, which have multiple things or multiple YAML files within a single thing, right? I'll come from the first team. So what I'm doing is that first of all, I'm creating a persistent volume, which means that I want to data my database data to be persistent. So I'm getting a storage for me, the persistent storage of 1000 MB or 1 GB data, 1 GB storage from my disk. From my host, I'm getting it. This is the host path. On my host, this is where I see that my data will be stored from the database. That is what it is saying. And there's a persistent volume claim, we call it, which one will be used by this persistent volume, or which pod is going to use it. That is called as persistent volume claim. This is on the top level I'm showing you. Persistent volume and persistent volume claims work together to ensure that you get a storage or persistent storage on the host here, the host path. This is where you get it. Wherever your pod runs, basically, that is where it's going to do it. After that, team, I'm doing a deployment of your Mongo database. Look at this. This is a kind deployment. I'm doing a deployment of Mongo database. I'm running a replica of one here. That is what I'm getting it. So here I'm using an image called as this one thing, learn DevOps Mongo image. Now this Mongo image within the container, the Mongo database is residing on this path. So I'm mapping this path to my persistent volume path. Basically, the mapping will be done. So here it is. So this is where I'm mapping my external host path to the internal container path. Internal team inside the container, the Mongo database is stored in the database here. This database path is mapped onto my local host path. So it is going to write the data onto the database, onto my host accordingly. Now let's say that here, this is exposing as a service. The service definition also I'm giving it here, which is going to be accessed for you. Now this is the second deployment which I'm doing it, which I'm running. This is your application basically. Application has multiple instances, right? So this is going to two replicas basically, and this is a Spring Boot application. A Spring Boot application is this one, the Spring Boot application which accesses the Mongo database to write the data to the database here. That is what I'm going to use it. And this is also exposed as a service team, a node port service, so that you could access that application from the browser accordingly, right? So let me deploy this application team, not getting into this one, but let me deploy this application here. kubectl create as what I wrote, create -f and my app.yml, right? So it is going to create the necessary stuff for you, whatever is necessary for you. Now let's check this once, kubectl get deployment, right? See that I think your application is up and running, but the database is still not available. It is maybe taking some time to come up because database is always a huge process. Now you see that this is available for me. Means both the application instances and the Mongo database is available for me. Let's say that kubectl get parse -oyt. I'll look at this one. Look at this one team. You can have a Mongo database pod which is running on a node called as 194, and your application is running on a node called as 173. Now let's access this application team. Let's access this application, which is kubectl get services. We have it because if I want to access an application, that will be a service there. So you can see that my app service is available for me, which is exposed on the node port, which is 30961, right? Let me access this one from the here. So here it is 30961, simple thing. Now you will see that my application would be launching here. Okay, it is huge. Let's say that this is my application team. This is that a Spring Boot application which is trying to write some data to the database accordingly. So let me enter some values here, which is Naresh, whatever it is here, whatever the mail you have, it submitted, right? Now it is writing the data to the database team. You guys also try to write some data to the database here. You may access the URL team within your browsers also. If you are in front of your system, basically, please try to access this application. I'm pinging the URL, right? I'm pinging the URL here. Hope you're all able to see the URL team. If you're all able to see the URL, access it, and you will be able to see this application in the browser. Right, once you have it, try to enter some data and enter your details here. It will write the data for you, right? So I can enter multiple values also here if you want it. Let's say that here again I'm entering it. Okay, so here it is team, some values I entered so far. I'm not sure if you're all trying to access this or not. So let me know team if you're all able to access it. Yeah, I see something here. Test one, somebody entered a test value here. That's great. What about others? Whatever that is, right? You're able to do it. So it is writing some data team here. Okay, consider that team, this application is writing the data to the database. That's what I told you. Now if you want to see that way the database is storing the data to you, now this is where team, you can see that this database pod is running on a node called as this one, right? Let's go to this particular node team. Let's go to this particular node, which is 194 node, which is my worker node basically. This is a worker node team. On this data, basically, you must see that under the /db data. This is where you will see all the data which is written, right? See that a Mongo database is writing the database here. Whatever the data you've been writing here, it is all stored here itself, right? Which is on my database, on my Docker hosting or a Kubernetes worker node, basically, not within the pod or within the container, basically, right? That's how you can understand about it. Let's say that here I see only one value so far. That's great. No problem here, team. So let's look into this one. What I'll do is now that I'm going to simply bring down this pod, basically kubectl get deployment, I'll say it, right? Deployment. Now within this one team, there is one pod running it. Let me scale it to 0. Let's say that kubectl scale, right? Deployment called as MongoDB, right? MongoDB. And let's say that hyphen replicas, right? We wanted 0, means that there is no pod should be available. Let's say that 0. Say that scale to 0 right now. Let's say that kubectl get deployment. Now say that there is no Mongo database is running team. If I say get pods again, so there are only 2 application pods are running for, right? Now let's say that team, this time if I go and write some data, I see that the data is gone because it is nowhere it is accessing the database right now. The data is gone. First of all, if you try to write some data team, if you try to write some data also, application would throw some error for you. Application would throw some error for you because it's trying to write some data to the database and database connections are not available for you. Since the database itself is not available, database connection would not work. Now it must throw me some error, right? Let's look into that team. Let's look into that. It is going to throw me an error or not. Once it throws an error, basically, we will try to look into the data again. It is taking some time. Socket exception takes 30 seconds again. You can see that there is an error that is popped up right now. It says that white label error. I would say that team very clearly that com.mongo socket exception, right? It says something that it says socket timeout exception connection timeout. So it says that something is not available here, right? So the server MongoDB is not available. That is what it tells you clearly, which means that my Mongo database is down. So my application trying to communicate with the database, which is down, right? That is a problem basically. Now let me bring up this one team. Since I deleted the pod here team, you can see that the container gone, but the still data is available on my Docker host here, which is not gone anywhere. If I restore that, if I restart my Docker, Mongo pod again, it is try to read the same data here. The data will be available for the database again. We'll look into it, right? Let's bring up the pod. Let's see that the same thing. I'll say that replicas one now again. Now it says it is scaled. Now here is setting. You can see that my Mongo database is running again, right? Now if I go back and get the data, first of all, let's say that my application is available. Look at that. My application is available, team, and you see the data also again, right? Did we do anything, team? Did you see the data is available again here, right? We see the data is automatically came up, right? Means in this case, team, try to understand that if the data was available within the pod or within the container, since we deleted the pod or deleted the container, data should be lost, or data would have been lost there, right? But we didn't lose the data because the data is available on my Docker host, but not on within the container. Even I remove the container, the data was available. Even I bring up the database again, the database was able to read the data from the backend databases, whatever it may be, which is a persistent database for me. And then that is how you can understand about a persistent database applications can be deployed within your Kubernetes cluster, a front-end application that is accessing database. A database is writing the data to the disk directly instead of writing within the container using the volumes concept. Now, this is how you can understand about the, making the persistent storage with the containerization also. That is possible solutions are available. We can do that, whatever the way you want it. You can run the database processes within the container, but the data will be written onto a disk again where the permanent storage is available. Now this is how team you can understand it again. And if you want to enter a few more values here again, you can enter it, right? So like this, it will again going to write the data to the database again as soon as the database is available for me, right? This is how team you can understand about single database connections here. This is how you can understand about it. But I think this is all about the Kubernetes also team that we wanted to discuss. I hope you all okay with it. This is all the things we want to discuss. We are done with the Kubernetes and Docker for now. And then if you have any questions now, I'm open to the questions. Please do let me know if you have any questions. We can start, discussing your questions accordingly. Any questions? Yes, team. Anybody have any questions? So I'm waiting for your questions, team. If anybody wants to speak, please speak. Any questions, we can answer. Any doubts, you can answer. I can answer your questions. I'm not hearing anyone's voice, team. Not sure if you're all okay or raw. Okay, there is some issue from the organizer side, I believe. He's not able to do it. Just give me a second, team. Let me check with our organizer once. Just give me a second, okay? Okay, guys, I just spoke to the organizer. I think his machine got restarted, it seems. He's logging in a minute. He's logging in a minute. Once he logs in, team, he will be able to unmute you because I do not have the privileges to unmute you guys. So once he logs in a minute, he will unmute you guys and you can speak it accordingly. That's what you can do. Okay, seems to be the organizer online. Hey, Kumar, are you there? He didn't join the audio yet.
I have unmuted everyone.
Okay, great. Yeah, guys, please speak. If you have any questions, please to speak and then ask.
Hi, Naresh, Bala here.
Yeah, Bala, tell me.
Just a couple of questions. So one is that when we attempt the certification, right? So the questions will be across all these topics that we are seeing. How is that going to be?
I think that Kumar can answer that one, not me.
Okay.
Yes.
Yeah. So whatever we are teaching in this workshop, so the high level everything will be covered, but not in the foundation exam is quite easy as compared to other exam.
Mhm.
So we are touching upon all the topics, but not in very much in detail.
Oh, okay. Okay. That's fine. So by end of the session, are we going to get some learning materials or something? Or
Right.
how is
So
that?
at the end of the session, by tomorrow, you all will be getting the email with credentials to access exam portal, and we will be providing you mock exam link so you can practice as much as you can and multiple times, and you can go through those videos. You can go through the commands that we have already shared with you. So in a way, you will be having ample amount of time to go through stuff, and you will be able to clear the exam without any major difficulty.
Yeah. Thanks, Kumar. And the second question is, Naresh, so what else is pending for tomorrow so that we can just run through them and come up with an
Okay, the
understanding of the
tomorrow
question.
we're going to discuss about a tool called as Nagios for infrastructure monitoring, and we're also going to discuss about a tool called as Splunk. That is a logging tool. How does it help you to troubleshoot your issues, or how do it help you to monitor your infrastructure again? And finally, we're going to look at a CI/CD end-to-end flow once. That is what all we're going to see. Okay,
Oh, okay. Yep. Thanks, Naresh.
thank you. And there is
Uh,
one question I see it in the chat. Please discuss later or tomorrow briefly regarding the Docker Compose and Docker Swarm. Docker Swarm is similar to the Kubernetes. I'm not sure who's the one who asked that question, but that is simply I'm answering that a Docker Swarm is similar to the Kubernetes. Okay, instead of a Kubernetes, you can use a Docker Swarm as a container orchestration solution. The same features that we discussed within Kubernetes right now. How does it help us create multiple containers, scale out, scale down, auto healing feature, desired state feature, as well as your load balancing feature, whatever we discussed just now, it is exactly the same thing that Docker Swarm going to provide you, right? So it is just that a Docker Swarm is from the original Docker organization, and Kubernetes is another vendor like open source container orchestration solution. That is what all about it. The comparison can be done quickly so you can understand it. The Docker Compose is, I told that this is a simple orchestration tool which is used by the developers basically. Within a Docker Swarm, we use something called as a Docker Compose YAML file. Like you have written a YAML file here for this one to deploy the deployments, which is your manifest file, we call it here. Within a Docker Swarm world, we have something called as a Docker Compose YAML file, within which you write a set of instructions to deploy your containers accordingly, right? The comparison scheme is that Docker Compose YAML file is equals to the Kubernetes manifest YAML file. That is what you write it. Here you wrote a YAML file to deploy the set of containers from a single image or multiple images. The similar to that one, Docker Compose file is a file basically which has a set of instructions to create a set of containers from a single image or multiple images accordingly, right? Along with that, Docker Swarm cluster remains same thing as your Kubernetes cluster. There also you will see one manager, two worker nodes, n number of worker nodes. You give the instruction to the manager node, and manager takes care of delegating the containers onto the worker node. The structure remains same thing. To be honest, this is what you're gonna do. I think so. This is how it is. I think I have with this clear explanation. You can see this one. Meanwhile, if you have anybody have any other questions, you can let me know, and we can discuss them accordingly.
Okay. Hi, Naresh. Actually, to be frank, actually, today's session was a little bit of in between. I felt a kind of a Dutch. It's not because of the way you explain, but it is because of for us, because there is a kind of a slight deviation from the Docker container pod. Like when I say the Kubernetes will be on the top and then the pod, and pod will be inside a container. I think we need to refresh the things. But I just had a couple of questions actually.
Yeah,
Um,
sure.
yeah, the first thing that we had that I had is like uh, we have multiple commands, right? So instead of avoiding this, you have prepared YAML file, and you also explained that how we can use the Kubernetes own mechanism to generate YAML file. But can we get that YAML file that is used by you for that web, like having the database connection and everything, just for our reference or something, so that we can practice tonight? Yeah, exactly. Yeah, this
I
one.
think this is we already shared with you, I believe, right? Haven't we shared this repository? Everything is available within the repository, including all the commands.
Oh,
I
okay,
think
perfect. Okay.
repository, right? This is
Uh,
available within the repository itself. Go through
okay.
this repository. Within the cube folder, you have all the pods, definitions, and everything is available. Look into
Okay.
that. Okay.
Okay, yeah. I think, and the other one that I had right up the mainly from the previous topics, right? We had like the GitHub. We created the WAR file using a package and everything. So that the linkage of all these things, right? So when we go through a continuous integration and a delivery, right? How we can like. And now there is a kind of we almost there, but I feel like some kind of linkage is required to entire this end to end, like Ansible has one in between, and GitHub on the other end, and then the Docker is on the third step. So all this tree can be linkable, or can be like
Right, they're all linkable basically. So I'll show you on the GitHub repository which I shared you. There is something called a CI/CD flow, right? Do you see my screen?
Yeah.
If you see this one, basically there is a guide. I kept it. Create a CI/CD pipeline on Jenkins using Docker and Ansible and everything here. By tomorrow, basically you go through this document and try to understand how everything can be integrated within Jenkins. Because anyway, I'm going to demo this one tomorrow once you have understood everything else. And with the whatever understanding so far, we could link everything like this. You can see that there is a step-by-step instruction which I have given. So how do I implement a CI/CD pipeline by linking all the technologies that we learned so far? We can do this one completely. Go through this document by tomorrow. Anyway, I'm going to demo it and I'm going to explain this again. How do we link each other to achieve the end goal of CI/CD pipeline? Okay, this makes sense?
Yeah, sure, Naresh. Thanks a lot. Yeah, that's good.
Yeah, go ahead with this one. Yeah. So, and there is an image also available here, the CI/CD flow image. How do you do it? So go through this image also, you'll understand that the flow of each and every tool, where exactly it fits and how exactly do it. Go through this picture, the picturization of this one, so you will understand the things accordingly. Okay. Yeah. Any other questions we have? Okay, so I do not see any questions yet. So yeah, team, for everybody also, please try to go through this document and the picture here available to understand the end-to-end flow. And this one, you can try it on your own also with all the instructions I given here. If you could implement it yourself, you will get a good knowledge on the entire CI/CD workflow, what we are trying to give you with this course as a top level. Again, I'm telling you, not in details, but this is how you can understand about all the things accordingly. Okay. So simple thing. So there are many things I think we already created about CI pipeline already. We're going to extend that to CD pipeline tomorrow, mostly after understanding a couple of tools within your section. Okay. Anybody wants to discuss anything, team? And there is a lot of information about whatever I'm discussing here. Each and every command that I'm writing, having a clear instruction that is available. In fact, there is a lot of information apart from what I'm discussing it. If you can follow through all this documentation, I bet you can, easily understand all the things what we are trying to achieve. I know for a Kubernetes team, Kubernetes and Docker, it is for the first time when you hear a concept of pod or Kubernetes architecture and everything, that takes some time for you to understand for sure as a beginner level. I understand that, but when you start hearing it multiple times and you start practicing the things, you will understand it easily. So please go ahead and practice it. The only mantra for this is that practice, practice, practice. The more you practice, the more knowledge you gain it, and the more questions you can ask me. Okay. When you don't practice, you don't get any questions. Also, definitely you won't practice, you more questions comes up. So I'm expecting more questions tomorrow to answer all of your questions. I'm ready always. So please do something and let me know the things fun. And that's all for today. If you do not have any questions, I think we can wind up the session here today.
Naresh, sorry, just the last one, please.
Yeah, please go ahead.
How long we gonna have the access for this link?
The GitHub repository.
Yes, indeed, that's the one.
I mean that should be lifetime for you. I believe there should not be. This is permanent one, so we're not going to delete it. It is always available. Okay.
Okay, fine. Thanks.
Sure. Thank you. So yeah, then we are good, I believe. So thank you so much, everybody, and I'll see you tomorrow. Have a great day or have a good evening. Take care.
Thanks, Naresh. Thanks for your.
Bye.
Bye.
Thank you.